Good morning and welcome to the 19th Greener Shipping Summit organized by Newsfront Naftyliaki with the support of Martekma. Today isn't just another conference, it's a call to action for a cleaner, smarter and more sustainable shipping industry. A huge thank you to our sponsors for making this event possible and to our incredible speakers who will challenge and inspire us with their insights. Your presence here shows that together we can steer the industry toward a greener future. Let's get started. Let's share ideas and let's make waves for change. George. And now George actually will open the conference.
Good morning, ladies and gentlemen. We're glad to be here with you, and we will start with the keynote speech that will be given by Mr. Panos Kourkoundis, who is the Technical Director of Sea Traders and also the Chairman of Martekma. So, Mr. Kourkoundis, you are welcome on the floor.
Good morning, ladies and gentlemen. Good morning, Chairman. Thank you very much for this opportunity. I will be the first speaker, the keynote speaker of today. And it's a great honor because actually this is the most, if not the most one of the most interesting conferences that we have and we are doing every year. I could not start with other than with IMO Net Zero Framework and what happened during the last MEPC just last month. I think that everybody still is discussing, and I think that we will discuss about this for some time to come. Personally, I don't see winners and losers from this MEPC. I see only winners, and the first winner for me is actually IMO itself. Because by ratifying a measure that would create lack of a nightmare with lack of consensus, with strong opposition, that IMO was risking to become involved in a geopolitical issue. And we have seen up to now IMO supporting the industry with excellent regulations about safety, protecting the environment. And in this case, we had so much discussion, questions, and ambiguity in this regulation that I think that the best thing that had to do it was actually do not be involved in such a geopolitical row. Now about the environment, if it is for the benefit or not, if it is one of the winners, actually we don't have a proper analysis. We don't have impact assessment of the regulation on environment. Even if it is an environmental regulation, it's very strange that there is no any formal assessment what we are expecting, what will be the impact. But we know that the regulation was supporting alternative fuels, was supporting the synthetic fuels, and we have the numbers. Aristotle said that there is no good and bad in arithmetics, and if we see the numbers, we will make an assessment of what was going on. We know that the fuels that were promoted in IMO were not available. Actually, just 1% of what is required for shipping was available in the market at the moment. And also, their production was not something that we could do the next day. We say that actually to produce ammonia for 1 ton, you need 10 to 13 megawatt hours. And at the end, you yield 5 megawatt hours. For methanol, you need 12 to 15, and you deliver only 5.6. So the energy that is consumed, it's much higher than the energy is produced. The global requirement in order to produce this fuel only for shipping was 5,170 terawatt hours per year, while at the moment solar panels and wind park produce globally 3,935 terawatt hours per year. So the requirement in energy, in electric energy, in the green energy was 131% of the global energy, just to decarbonize shipping. Also, the cost to build this infrastructure, it was 1.25 to 3.7 trillions. And that was only for 20, 25 years. This is the lifetime of these parks and panels. So, as Oldfield had calculated, the energy that was spent for decarbonizing shipping was giving one ton of reduction of CO2, and the same energy could give 9 tons of reduction of CO2 if it was used in the land transportation, 8 tons of CO2 if it was used for heating the house with pumps, with heat pumps than using the fossil fuels we're using today. So this, considering the cost of the electricity, considering that the fuels are consuming much more, I don't think that the environment has to regret that finally this energy will not go, or at least for the moment looks that it did not go for the shipping industry. And also regarding the cost, we calculated, and this is also even in the World Bank data, that IMO had intention to collect 4.35 trillions and to become the 5th biggest entity to asset or for the asset management. So it was a huge amount of money out of the much more higher than the budget of countries. And I don't think even the shipping has to regret this development, because this amount of money definitely will have an impact in the global trading and also in shipping. So what next now? How we will proceed? We need some other actions. We need some other regulations to come in force. And to support what, if it is not the alternative fuels? We don't have energy like light batteries. We talk about nuclear. Nuclear still is not ready, and also definitely will resolve the problem of global energy, but environmentally the problem remains, and this is the nuclear waste. So we should not be fooled that it is not, that it is environmental friendly. There is no, for the moment, application. That will be an illusion that there are reactors like molten salt reactors or otherwise that produce negligible or harmless radioactivity. And we have seen that we try to diminish the problem of radio wastes, and very often we hear that these new reactors, they produce just a small quantity. This is the size, or it is like a swimming pool, or it is like a small box. When we start measuring radioactivity by the ruler, it is like measuring also electric energy with a ruler. So we should be very careful when we talk about environment and nuclear, even if it is a solution that will come, but to resolve the problem of energy and not the problem for environment. So unless we have new technologies, we should move with what we have now. And what we have now today is called improvement. And there is a lot of room for improvement on everything we have in front of us. We can do it a little better, and all of this together, it is definitely that it will do also better to the environment and we will have results. And it is expected that we can still with the technology we have now, we can even reduce emissions by 50% of what we have now. So, but shipping is not all about the environment, and I believe that IMO also will start be focusing again in safety, in reliability. You should not be surprised if within the next decades you have the control of a ship in your mobile phone. This is something that will happen. It happens already with almost all applications we have in our daily life. So ships, definitely the systems, will have automation, will have remote control, we have predefined scenarios, and this is the road forward, and this is the way that we are expecting also the industry and all other parts of the industry to work, to apply regulation that will accelerate this development in the shipping industry, and I think that that will be for the benefit of all. So I wish we have a very interesting conference today, and thank you very much again for inviting me as a keynote speaker in this conference.
Thank you, Mr. Koukounis. And we will start with the first session, decarbonization. Can IMO bring it back altogether? And I will invite my colleague, Christos Hatzigeorgiou, Managing Director of Alvin Marine Management, to moderate this session.
Thank you, Mr. Chairman. It's a real pleasure having you all here, and we have an extremely good panel of speakers. I will invite Mr. Lefteris Kokoulopoulos, the Regional Decarbonization Specialist of DNV, to come up with his presentation.
Thank you very much. Good morning, everyone. It's a pleasure to start with today's discussion. As Mr. Kourkoudis stressed, it's definitely interesting times. It's a very good timing for this conference after the delay of IMO. That apart the fact that it was something mainly driven from the US and the diplomatic pressure that was applied on all countries, we should take this opportunity to reflect that, as Mr. Kourkoudis said, we need more realism in shipping. These are some numbers that show a clear trend that all transportation is increasing, population is increasing, people are ordering more and more goods, they travel more. And along these figures, at the same time, we need to decarbonize, which makes this even more difficult than it is. There is also the question that we should reflect if this is a threat or an opportunity. It is compliance on some extent, but also it has to do a lot with the competitiveness and how its company wants to position itself in being at the front. And we see still that in some cases, using decarbonization as a business model is working for some stakeholders. And to start off, the last minute question is this happening? Let's see some numbers from our latest study, the latest maritime forecast of DNV that was issued September, before IMO. And what we see here is, at the top graph, we see 9% of the current fleet can burn something different than fossil oil fuels. The number is small currently, but it's more interesting to see what is happening in the order book, where we see a bit above 50% of the gross tonnage that is able to burn something different. Mainly LNG and methanol for the time being, but we see also other fuels coming potentially in the future. There is a gap between the uptake for different ship types. Bulkers and tankers are behind. It makes sense of their type of trade, while it also makes sense for container ships that lead this uptake, because we are talking about the largest container ships operating in a fixed route. And another interesting fact is that containers have made a lot of money over the last 2 to 3 years, even more money than they have done the last 10 to 15 years, making this even easier for them to invest on such technologies. The same information per fuel. We see LNG, methanol, the same trend as we noticed before, container ships having the lead. But what is interesting is the last graph about ammonia, where we don't see any container ships here, and we see 11 bulk carriers. This is coming to what we said before, that if the business case it makes sense, a fuel or a technology can go ahead. And these 11 bulk carriers are some very large ore carriers that are going to operate on a fixed route between China and Australia. And the mining companies are the ones that are going to also produce the green fuel for these vessels. So we may see some initiatives like this going ahead. Additionally, in this year's maritime forecast, we calculated all the capacity that the fleet can burn in 2030. So this is what shipping can do in terms of consumption. And it will be able to consume 50 million tons of equivalent oil until 2030, mainly driven by LNG. LNG is a mature technology. We have the technology on ships, we have the technology on land, and also bio-LNG at some point can be injected in the system to harvest the positive effect on the regulation also for LNG. But we see, okay, shipping has done its part. What is happening on the other side? What is happening on the supply side? Based on the analysis that we did this year and the forecast we have until 2030, 2032, we have a low and a high scenario. And this white dotted line is how much fuel shipping will need in order to achieve the current IMO target. So it lies between 1/4 to 1/3 of the global fuel consumption, which, coming also to the opening speech, it's a lot to need only for 3% of the energy. This means that we are going certainly to need other technologies. Just to take a step back and come to what happened last year, one of maybe the busiest port worldwide in Singapore, where the numbers are small, 2.3% of the bunkered fuels was an alternative fuel. But the positive side is if you compare 23 to 24, we see that this quantity has doubled, at least. And the main fuels, of course, is biofuels. It is the easy fix for now that we can use on existing ships. LNG, methanol follow next, and we see a tiny portion of ammonia, this 9.3 tons. Where these 9.3 tons have been consumed? They have been consumed in on this vessel. This is Fortesque Green Pioneer. It is the first vessel that tested ammonia as a marine fuel. An important fact also it is that it's classed with DNV. And this also comes to what we said at the start, that a very rich guy in Australia decided to invest on this project because they are going also to have a green fuels arm in their company. So they got into test case also ammonia as a fuel on this vessel. Everything happened on deck. The existing engines were retrofitted to consume ammonia, and it was a case where a lot of lessons were learned for the safety and hands-on experience of this fuel. And it shows that if there is a drive for other reasons, industry can move even ahead from the regulations. And as we said before, we are going to need more technology, we are going to need more tools in our hands in order to achieve these targets. We have selected just 2 of them from our year study to showcase here. First, we see an interesting trend in wind-assisted propulsion, where currently we have 50 installations, with 100 more being in the order book. A lot of technologies. Mainly we have rotor sails, action sails, and wing sails, and at the right we see the uptake from different ship types, where tankers and bulk carriers are having the lead, at least for the time being. A lot can say someone for this technology, but what we should keep is that for the time being, it's something that varies a lot from ship type and the trade routes the vessel is operating. We may see some very good results for one pass, but if we annualize all the numbers, the result is something different. And also the majority of the existing projects are some type of co-funding along with the charter and the cargo owner, even from EU Innovation Fund, in order for the return of investment to make some sense, because these numbers are quite high right now. These numbers and these figures have also included in this time in AFI. AFI is our portal called Alternative Fuels Inside, where anyone can access this uptake and the adoption of all the technologies, both fuels and technologies, like the wind-assisted propulsion. And closing, carbon capture is going also to play some role in the next years. In this year's study, we started and we isolated the largest bulkers, tankers, and container ships. And by using the equivalent sizes of LNG tanks of the LNG-fueled vessels, we found that this storage capacity may be enough for a year's CO2 storage for these big vessels. And also, we approached it from the other side, from the ports side, where we selected the 20 busiest port right now. And theoretically, if there was an offloading infrastructure there for CO2, this would result in 19% reduction of emission for that part of the fleet, the largest vessels, which corresponds to 9% of the emissions of the world fleet. And just a closing slide to see that we are going to need a lot more options in order to achieve our targets. We discussed about fuels and biofuels, energy efficiency, extremely important because the cheapest fuel is the one that we do not consume. Fuel cells, carbon capture, and nuclear, something that may come along down the road. Thank you very much for your attention.
Thank you very much, Mr. Kokoulopoulos, for a very, very informative presentation. Next in line is Mr. Michas, the Marine Southeast Europe Tanker Key Account Manager of RINA. Mr. Michas, you have the floor.
Hello, good morning, everybody. There will be some overlaps because I think all of us have some similar slides, so I have some similar with Lefteris. So also Lefteris talk about how many vessels are now equipped with alternative fuel engines. Lefteris said it all. We see only mainly in container vessels and very big tankers. And we have to say that the last year we didn't see this increasing, especially in tankers. We see more tankers ordered with conventional fuel than it was the previous year. And I think this says something that something is not ready, something is not correct. And we showed this also last month with the MEPC. And sorry. The question is now what fuels we're going to use. Because the green fuels that is IMO is trying to push us, actually they are not there. And I don't think they will be there even in 10 years because we don't have the capacity to produce them. LNG is a fuel that until now, everybody was thinking that is the next step, but we saw that IMO was trying to ban this and it was really not promoting LNG with the regulation they want to pass. VLSFO is the one that we all love, but it will come to an end very soon. And biofuels, of course, there are here, but how much biofuels we have and which industry will take first. Of course, there are some differences between the biofuel for shipping and aviation, but definitely will not be the amount that we would like to have. Regarding the MEPC and the NZF, there is something that we have to consider. There are some countries said there that we want to have only the taxation from IMO and not many others. And even if it's good, that maybe good, let's say, for many people that this has been postponed because there was a lot of issues about the NGF regulation, about the way, why it was so much money, where this money will go. There was a lot of issues that maybe has to be resolved to make it, this regulation easier and better to go to the next step. Also, we don't want to have 5, 6 different taxation policies from different countries, like we have in Europe, we have in China, Turkey, in Africa, some countries want to have. This will make maybe more expensive the transportation and maybe also very complicated for the operators. Something that impressed me, something I have to tell you I didn't know, let's say 1 month ago, is this Sustainable Transport Investment Plan. So this is coming from EU. And it says a lot of things that is also what we used to say. We have seen that the EU was the first that make the steps for giving a lot of taxation and try to make measures for CO2. But we see that here they mention a lot of things like if fuels are not available here, we see that for biofuels also the availability of sustainable stock is not enough and is competing with other sectors. Also, they suggest other means. They suggest wind assisted propulsion, and they suggest also to continue use fuels like LNG. So we see a lot of this is controversial if we can see what IMO says, what EU was saying before, and what we have now with this forum. That this is from a European Parliament. It's not. So it's very interesting. This means that the people start thinking that maybe the way they were thinking to go ahead was not the right way, and it was a dead end. Because we want transportation to be able to do it, because otherwise it will be so expensive that nobody will be able to buy anything, because all the costs will go to the end user at the end. So as Mr. Kourkoudis said, because for the green fuels, we need huge amount of energy to produce them. If we use all the green energy we have at the moment, we can just produce fuels for the shipping, that we are 3%. So this means we need to make billions of wind turbines. Maybe this could be feasible if we have many more nuclear reactors on land to produce these fuels. So at the moment we have very small quantities, and in the next years we'll not be able to have much more. So it's really questionable, these green fuels, because we're discussing many years, and I think all the industry, we see where we were 5, 6 years ago, we were saying, yes, we have LNG, ammonia, methanol, LPG, but what is the reality? Do we have this, and when we're going to have it? And I'm not going to talk details about toxicity, and I think the most of us here have some beliefs about ammonia and the toxicity, and many people are afraid of this. But even this, we don't have enough. So for other solutions, okay, we hear a lot of things for nuclear. There are definitely new technologies that is not like in the past. Personally, I think that this is very, in the future, will go. There are many things. First of all, we have to change the people belief. Most of the people believe that the nuclear is like Chernobyl. So I think we need a lot of generations to pass and to persuade people that this is maybe more safe. But I agree also with Mr. Kourkoudis that anyway, there is some waste. There is nothing without waste. Of course, it's very nice to say that I have a fuel that will never refuel again. CO2 tax is very low. There are a lot of positive things, but we have to resolve a lot of issues. And also, where we'll find the people that can equip, that will travel with these vessels. we doubt if the people would be able to travel with gas fuel engines. With this, will be very, very challenging. And batteries, the batteries technology at the moment is emerging. From year to year, the quality of the batteries is increasing a lot because it's huge investments for this on this field. Maybe now, 2 minutes, okay. Maybe now it seems that say, okay, for a big vessel, how? Because we know we have some small vessels, some ro-ros, some like a vessel who say Palukia, Perama could do it. But actually there is a lot of advantages in order to take the peak of the load. You can have ultra steaming, ultra low steaming, zero emissions, so there is a lot. So I want to go a little bit fast because what I want to tell you more is I believe, we believe that CO2 capture is something that is really maybe the main thing that we go to invest. And we have, of course, the CO2 capturing, the post CO2 capturing have a lot of issues because of the nature of the gas is difficult to have a very big amount of capturing of CO2. Also because of the sensitivity from the NOx and SOxes, we see that the chemicals very soon will not react well. So what one proposal we have is for pre-combustion capturing. This is existing technology. You use LNG, and you can use fuel reforming on board. So and you produce hydrogen. Hydrogen is the dream fuel. The dream fuel for the future is hydrogen for all industries. The problem is how to carry it, how to transport it. But with this case, you can produce it on board. You have, in the same engine, you can burn LNG and hydrogen because you can burn hydrogen in 2-stroke and 4-stroke engines, even in gas turbines you can burn. 1 minute. And actually you can change the proportion of LNG and hydrogen you burn, and you collect CO2 that is clean CO2, because with the pre-combustion technologies is not clean, so you need further procedures to clean it. Here is clean CO2 that you can give it outside. This is one. We see one concept. We have we have worked also with Almi and Sdari. It's a bulk carrier that actually is mainly for electrification, and we use also the technology of with the reformer and hydrogen. It's something that really gives very, very positive results. Finally, if we were coming here last month, we would make one model here, how much money we would save if we have also the taxation of from IMO. But now we're not sure. So here is only only EU, and I have not added the solution here with the hydrogen, but we see even with LNG only, the money that you save, even if you have 15, 25, or 50% time spent in EU, the number down in the yellow is millions that you will save. If we make this also with the previous version, I can tell you that this will be more than 10 and 15 and 20 millions saving from taxation. Okay. Thank you.
Thank you very much, Mr. Michas. The next speaker is Mr. Michael Fan from Tsakos Energy Navigation. He is the Chief Technology and Innovation Officer, and he's going to give us the perspective from a shipping company. Mr. Fan, you have the floor. Thank you.
Thank you, Mr. Chairman. Good morning, everyone. We more or less cover the same things, but hopefully I'll put it in a rather different light. So this is the main topic of discussion since the 14th of October, where we had this non-vote at the IMO. It was an opportunity, the world's first global, legally binding carbon pricing that's ever been imposed on any industry on this planet. A truly landmark moment for the shipping industry that didn't take place. The mechanics of what actually happened on that day or throughout that week have been covered on many different fora, so I will not bore you again here. Suffice to say that this is the result of the non-vote. 57 countries voted for a one-year-long adjournment, 49 against, and 21 abstained. It is very notable here that amongst the 21 countries that abstained were Greece and Turkey, breaching the rules for EU block voting for the first time ever, and thankfully taking on board the views of the huge shipping industries that they represent, which express strong misgivings about this carbon taxing regime. The big question from that monumental non-vote is whether the deal is delayed or it's completely derailed, sunk without trace. The optimist in me says that the direction of travel hasn't changed, and if we use the intervening 12 months to put the meat on the bones that was the original net zero framework of April 2025, which we're sadly missing, then a more complete NZF 2.0 can rise from the ashes of NZF. On a personal note, and as a firm supporter of the need to have a global maritime regulator for what is a global industry, our industry, shipping, I sincerely hope that the IMO uses the next 12 months to understand the needs of the shipping industry that is supposed to regulate and reflects them in a new version of this net zero framework. So, there are those who would argue that the 14th of October 2025 was an existential moment for the organization and it went wrong. However, for those of us who believe and support a global regulatory organization for shipping, it becomes even more important to put our faith in the IMO during these challenging times. But the IMO should also demonstrate more understanding towards the industry that is supposed to represent and regulate. The point is to find a clear path that is best for both the environment but also for the shipping industry, not one without the other. IMO appears so far to have ignored the experience-based views of the shipping industry, with politics exercising significantly greater influence on the proposed network rather than technical matters. We have always been firm supporters of the IMO and continue to advocate in favor of global regulation, which is paramount for a global industry like shipping. Now, I would like to highlight some of my views on what was wrong with NZF. Shipping is a business about owning, managing, and operating ships, and cannot and should not be contingent on the production and/or trading of fuels, which is not our business. We support decarbonization initiatives, but shipping should not be made to carry the can for much more than its fair share of global emissions, which is the case with the current proposed framework. So, to be more precise, the well-to-wake calculation is not fair for shipping. Shipping should only be responsible for the emissions of the fuel we use in the ship's tanks only, therefore tank to wake. In addition, the proposed GFI trajectories are very unrealistic. I will not go into details. My good friend, Dr. Kokarakis, explained them in excruciating detail during the last SNAMI Greek section meeting a couple of weeks ago, and I'll refer you to him if you need more details. And finally, the implementation of the proposed NZF will be highly bureaucratic and costly, with this burden being felt heaviest by the SMEs, which are the lifeblood of what has been the miracle of Greek shipping. Let us not forget that due to the absence of alternative green fuels in sufficient quantities, with the right infrastructure and at the correct price, the penalties imposed are nothing more than taxation without direct environmental benefits. Also, the proposed NZF unfairly disadvantages proven, safe, and readily available transitional fuels like LNG, which deliver immediate emission reductions. There should be a more pragmatic revision of the regulatory framework before entering into force. We also need to ensure that if a global network is adopted, then all regional regulation on shipping emissions should be withdrawn at the same time. Currently, there exists no assurance regarding the regulatory overlap and double payments for the same emissions. And just to put it into perspective, something that all of you here probably know, we transport 85 to 90% of the world's goods by sea. And our contribution, as you can see from these view graphs, to the marine emissions is the smallest of all. These graphs are taken from IMO's World Resources Institute Climate Watch publication. As you can see, shipping remains the lowest emission form of transport per kilometer traveled. So, what do? I mean, Tsakos, as well as most of the very responsible, well-managed and operating Greek shipping companies, have not been sitting on our hands. We have been working towards reducing our carbon footprint with drive and determination for quite a few years already. So, in terms of our company, Tsakos, we do this through a strategic fleet renewal program. We reduce the existing fleet's carbon intensity through technical and operational measures, establish a decarbonization pathway by using transitional alternative fuels, and we take part in various R&D projects towards net zero or carbon neutral technologies. So in more detail, in terms of our strategic outlook to fleet renewal, as you can see, this is from the 1st of January 2023. We divested 17 vessels with an average age of 19.5 years and carrying a total dead weight of 1.3 million tons, and we replaced them with 40 new technologically and environmentally advanced vessels, average age 0 to maybe 1.5 years now, and a total dead weight of 4.9 million tons. The new vessels include dual-fuel vessels. Tsakos has currently the largest fleet of LNG running vessels. We have 6 dual-fuel Aframax that have been working for almost 2.5 years now. Optimized hull and propeller design, installation of energy-saving devices on all our new builds like pre-swell ducts, propeller boss enhancing devices, rudder bulbs and fins, depending on the trading pattern of the vessel that we build. All of our dual-fuel vessels come with a shaft generator, and due to our good experience over the past 2.5 years, we're now installing shaft generators on all our new builds. We have variable frequency drives at various pumps and fans, and all 6 of our container vessels that were delivered at the end of 23 and
Time
during
is up, please.
24 have AMP installed. So in terms of the existing fleet, our operational measures include just-in-time arrival, and you can read all of it here. We have a comprehensive underwater maintenance regime that involves regular inspections, speed tests, and using this with our telemetry suite, we determine the appropriate time to carry out propeller polishings or full hull cleanings. We also monitor and adjust main engine performance, auxiliary engine management, as well as auxiliary boilers' internal efficiency. In terms of technical, I've already covered most of these. We have installed energy-saving devices. We use ultra-low frictional resistance coatings, installation of variable frequency drives, LED lighting in accommodation areas, and we are undergoing a program of replacing volumetric flow meters with mass flow meters. In terms of our R&D program, we are developing T-Permos, Tsakos Performance Monitoring and Optimization System. It's an in-house weather routing and vessel performance optimization platform utilizing high-frequency data together with first principles and machine learning algorithms to optimize the energy efficiency of the vessels in our fleet. This is currently in progress. We're undergoing beta testing on the voyage optimization part. We're involved in major research programs. For instance, the university where I am an emeritus professor, the University of Strathclyde in Glasgow, they have developed a new Eco Boss Cap design, and we are going to pilot that on one of our vessels very soon. And also, we are partners in the EU Horizon Orcelle project. I am a member of the External Experts Advisory Board of that, and we're collaborating with the National Technical University of Athens to develop conceptual designs and operational plans with wind assistance of the Ocean Bird wing that is used in this particular program on one of our Kamsarmax bulk carriers. So, to finish, early explorers only left with a clear goal to discover quicker trade routes or new resources. But often they set off without any clear journey plan, no detailed maps, not knowing where they would stop, and in some cases not even knowing their destination. I feel that today's energy participants are more like those early explorers. We have a clear goal to decarbonize the world, but we're moving forward without a detailed map, but a very high-level idea of the energy system we're trying to build. For some, this combination of a clear universal goal with a flexible and diverse pathways may introduce unwanted uncertainty. But for some others, this may represent historic opportunities for the way forward. What we must ensure, shipping has been on a pathway towards zero emissions, but the regulators must ensure that this does not mean zero margins, because the industry will die if that is the case. So, the momentum of MEPC 83 has been dealt a blow, there's no doubt about that. The global signal that shipping needed to invest in greener technologies is still nowhere to be found. But environment protection should not be used as an excuse to tax what seems as an easy target, the fat cow that is shipping. Climate change is too big an issue for the IMO to solve. The events of October the 14th was evidence that international law depends on politics, and politics will follow the law of the jungle, the eternal fight for power, wealth, and influence. Even if the NZF is adopted, it will not be a happy life as long as the world's major powers remain at odds regarding its goals. Thank you and apologies for the slight delay. I hope it was worth it.
Thank you very much, Mr. Fan. The next speaker will be Mr. Knudsen from Everlands. He is the Principal Promotion Manager of promoting, as usual, two-stroke engines of MAN.
Where do we click? Yeah? The big one, okay. Yeah, thank you very much, Christos. My name is Jakob, and I would like to explain about the market situation seen from Everland's two-stroke side or B&W side. Following that, I would like to introduce you to some of our dual-fuel technologies and give you a glimpse into the future on dual-fuel technology as well. But let's begin with the market. Following some very lean years, 16, 17, 18, up until COVID, we saw quite a boom in contracting. And our forecast predicts that this level will be maintained. Supporting that high level of ships contracting will, of course, be a predicted trade growth. Something that we have already heard about today, but also very much supported by scrapping. And nowadays we are at the historic mark of approximately 20 years since the latest super cycle of construction, followed by the financial crisis. And this is expected to give a strong support for contracting in the soon-to-come years. If we look into that contracting and look at the mix between single fuel and dual fuel, we have seen a steep uptake in the recent years, but we have also seen a clear leveling out, a distribution with 50-50% approximately single fuel and dual fuel contracting. And if we dive even more into details of that dual fuel distribution, we will see that LNG leads the way by the majority of the dual fuels, but also methanol has taken up quite a significant portion of that contracting. If we look into year-on-year or year-to-date 2025, we can see that we are slightly lower than the 50% distribution that I just highlighted before. One could speculate that ship owners already predicted the outcome of the recent voting in IMO. So it is clear that something is needed to sort of push beyond this approximate 50% level point, you could say. We attempt on a yearly basis to predict the fuel distribution, a forecast for distribution of fuels in the contracting. And if we look to begin with at 2025, we can see that the LNG, here marked with red, or methane if you like, is the majority of the sailing dual fuel fleet. But in proportion to single fuel, the gray, it's still a minor part. Leading up to 2050, we have a prediction where ammonia, methanol, and methane will play a significant role. Will this be the exact figure that we hit in 2050? Most likely not, but we continue to adapt our analysis, and for sure the recent voting last month will also play an impact on this forecast. If we look at our two-stroke products, we can see that the methane-powered products, both the MEGI, the high-pressure concept, and the MEGA, low-pressure concept, leads the way with MEGI surpassed this year 1,000 engines contracted. Methanol comes in at a firm 200 plus orders, and the so-called niche products that are specific for specific tankers, LGIP or LPG if you like, and ethane plays up a significant role in numbers as well. Under ammonia, we have not listed an exact figure because it is quite variable these days, and of course influenced also by legislation, as we have already heard. But I would like to underline that there is a good momentum still in ammonia, which I will come back to a little bit later. If we look to our our oldest dual fuel product, the MEGI, a little over 10 years in the market. We have gone from the concept MEGI Mark I, as you see pictured here, over to a MEGI Mark II. The MEGI Mark II is a cost-optimized and simplified system that even manages to enable more interesting functions for the operators and owners. Specifically, the double-wall chain pipe has been reduced, and this is a significant cost reduction. Also, some of our control oil piping on the cylinder cover area has been reduced or simplified, making maintenance and operation easier, and also reducing the capex of the product. One important function that is enabled in MEGI Mark II is the well-known gas cylinder cut-out function, where a gas trip on the engine would not knock out the engine's dual fuel running to single fuel, but only knock out the particular unit that would suffer a problem. This is a very powerful function that enables more uptime or higher consumption of dual fuel compared to single fuel. On the MEGI concept, we do in this slide highlight some of the primary components. We should consider all of our dual fuel engines as an added secondary fuel system to a single fuel engine, a conventional two-stroke engine. Here pictured with high pressure pipes for a pilot injection valve, control and sealing oil pipes, most important gas injection valve. Gas is distributed in the cylinder cover of the MEGI Mark II and handled by the gas control block you see with the yellow pictured here. Following the very famous MEGI came quickly a methanol engine, we call it LGIM, and it develops on the concepts of MEGI, and it was actually a tailor-made product for methanol carriers, so a niche product to begin with. But interestingly enough, the whole industry adapted this technology widely in all vessel segments in the recent years. It runs on the diesel cycle and therefore provides the highest possible efficiency. And it thrives off the design concepts of MEC, the electronic two-stroke engine, and the MEGI, the gas engine that I spoke about before. It has a very simple supply system, easily handled on board with only 13 bar supply pressure, normal injection pressures in the range of 600 bar, and a pilot fraction of 5% for an L1 rated engine. Similarly, we highlight here the concepts, and I think it's obvious to everyone in the audience that, again, we develop with the concept of a gas block and a secondary fuel system added to the primary fuel system of the engine. Pay attention again to the yellow-colored double-wall pipe that actually enables us to have a non-EX zone in the engine room. and therefore reduces the complexity of the installation. In the same family, the LGI, so liquid gas injection, we have our LPG burning engine, the so-called LGIP engine. LGIP engine is of course dedicated for LPG carrying vessels or tankers, and it gives some reductions in CO2 based on how it's viewed, well to wake or tank to wake. And of course it provides, like all the other dual fuel engines, the reduction in SOx or a SOx compliance, which is very, very interesting. Of course, from a compliance level, but certainly also from a wear and tear level when we're talking two-stroke engines. LPG burning engines are slightly different from the before-mentioned methanol. Supply pressures are slightly elevated, and LPG is a more complex fuel, and it's not a uniform fuel depending on the source of the LPG. Likely or similarly to the methanol engine, we operate that at a 5% pilot oil consumption, and any pilot oil, not only for the LGIP engine here, but for all of our dual fuel engine, can be any compliant fuel or synthetic fuel that owners may choose. The next slide here, I will pass. It mentions a little bit more about the components of the LGIP engine. The next chapter, ammonia, has been under development for quite some time, and actually tomorrow in Copenhagen we will have a ammonia engine launch event. So if we flip to the history here, we can actually see that in late 2025, beginning of 26, we are ready to enter the market more firmly with more commercial projects for the LGIP engine. But just like any of the other dual fuel engines that I walked you through before, the development starts really, really early before we are ready to deliver such a project or design to the market. So already in 2019, we started our development together with universities to simply investigate combustibility of ammonia. And up through the years, we have conducted significant development steps. We have erected a two-stroke ammonia engine in Copenhagen dedicated for ammonia running, which went to full-scale testing. And we are now running also a full-scale commercial engine in Japan. Just like the other dual fuel concepts, a pilot oil is needed, and we aim at the beginning to have a pilot oil consumption again at 5%. But for all of the dual fuel engines, and not only the ammonia, we expect to improve that over time. For its fallback mode or single fuel running, we target efficiency similar to a single fuel or engine, so a fuel oil mode, which is also important in the event that ammonia is not ready for the first couple of operating years. The ammonia engine is in the family of liquid gas injections, so LGI concepts, and you can see again a classic setup with a gas block combined with fuel booster injection valves, which I will come back to later, and then the famous double wall piping that ensures safety around in the engine room so that crew can operate safely the engine. Pictured here is our first commercial engine.
2 minutes.
Yep. Our first commercial engine, a 7-cylinder 60-bore in Mitsui in Japan. This engine has undergone a lot of R&D development test running for us to sort of accumulate and set basis for our following commercial ammonia engines. The big gray component to the right of the picture is our SCR reactor, and an SCR reactor is very, very important for running ammonia engine because it neutralizes the emissions, the ammonia slip, very, very harmful emission, and also laughter gas and NOx emissions. Lastly, and not only for ammonia, but I would like to highlight just what is the concept of all of the dual fuel LGI engines that I have mentioned. LGI means that we are injecting the dual fuel media in a liquid state into the combustion chamber. Some may know this technology also as a PD technology utilized by many engine designers over the last 50 years. So we combine a fuel pump with a fuel injection valve and inject the fuel in a liquid state. All right. Thank you very much for your time. It's a pleasure to talk to you.
Thank you, Jacob, very much. Next in line is Ms. Sophia Lindholm, the Operations Manager of Everlens Cryo, and Yada. She's going to talk about the critical role of fuel gas supply system design and integration in the fuel transition. Sophia, you have the floor.
Thank you. I would like to start with this statement. It is one of our slogans, and yes, it is a clever play on words. It reflects Everlens Cryo's expertise in cryogenic solutions, such as storing liquefied gases at low temperatures under pressure. But to me, it also has another meaning. Today, we are all under pressure, the pressure to create a sustainable future. And decarbonizing global shipping is essential in this. And while this challenge is huge, we must keep our cool, we must make the right decisions, and we need to take action where we can truly make an impact. So, my name is Sofia Lindholm. I'm Operations Manager at Everlens Cryo in Gothenburg in Sweden. And I'm here today to talk about fuel gas supply systems. So yeah, I'm a colleague of Mr. Knudsen, same Everlens company. But we are not only delivering engines, we are also delivering the systems needed to supply the new fuels to the engines. And I'm also here to talk about how we have partnered up with Yada Green Energy Solutions from China to continue to be a key supplier for the fuel gas systems. So, where are we now in the journey towards greener shipping? So we have the strong initiatives from both the IMO and the EU, and these are important steps to accelerate the maritime fuel transition. We have the investments growing in dual fuel solutions, as just presented. But of course, there are also challenges, as we know and have already mentioned. The recent postponement of the IMO Net Zero framework is, of course, a setback, but we cannot let this slow down the progress of future fuel development. The technology for green fuels is already here. So how do we keep on moving forward? Continued investments in proven future-ready solution is essential because we need to increase the fuel demand and we need to build up the need for infrastructure to be able to scale up the future fuel and make them price competitive. Finally, and I think most important, is cooperation. We will not solve this on our own. We need to cooperate. We need to cooperate across industry and across companies. And that is why Everlens Cryo has formed a global strategic partnership with Yada Green Energy Solutions. So our partnership began in 2022. Already in 2023, we reached our first joint major milestone. When shipowner BYD built new PCTC vessels at the GSI shipyard, Yada was the supplier of the fuel gas system based on Everlens Cryo design. Before I share some more details on the solutions that we have for the systems, I want to take just a quick step back to tell you a bit about the history of our both companies. So, who are Evelyn's Cryo, formerly known as MAN Cryo? As you can see, we built our first land-based cryogenic tank already in 1956. And since then, from our base in Gothenburg, we have become one of the world's leading providers of cryogenic engineering solutions. In 1999, we made history in delivering the world's first LNG fuel gas supply system to the Norwegian ferry Glutra. And we have supplied more than 60 LNG fuel gas supply systems over the years to different types of vessels. However, in 2021, we closed down our own manufacturing because the systems previously were produced in Gothenburg at our site. But this is now closed, and we are focusing on engineering, on commissioning and service. But this history is what makes our engineering unique today, with the 26 years of fuel gas supply system technology development within our engineering. But then, of course, we need to have a strong manufacturing partner, and that is now Yara Green Energy Solutions. They were founded in 1993, and they are clean energy equipment experts with a fully integrated industrial chain. So they have 2 production sites in China and a total of 15 specialized production lines. And one of their strengths is that they have a 4-level manufacturing capacity, meaning first level raw material production, second level pipe fitting processing, third level pipe spool prefabrication, and then fourth level skid manufacturing and installation. And for the fuel gas system production, this means that Yara is in control from day one, already from the pipe production, and all the way up to the installation of interconnecting piping and skidded units on board the vessel. And from our experience, this is a major advantage because then we keep the interfaces with external parties minimized, and it reduces the risk of delays and quality issues which you are not in control of. So, moving forward to the main topic of fuel gas supply systems. Due to a limited amount of time, I will focus on the most mature solution, namely LNG. LNG might not be the long-term future fuel, but right now it plays a crucial role. The technology is mature, the fuel availability is high, and the infrastructure is strong. Today, LNG bunkering is available in around 200 ports worldwide, and about 80 more on the way. With LNG, you will get an immediate emission reduction, and we take great care when we make our design that it's proper and safe to avoid the release of methane. And finally, investing in LNG is future-proof because your system will be compatible with either biogas or e-LNG, allowing your vessel to be emission compliant all the way until 2050. So, the LNG fuel gas supply system can be applied regardless of a 2-stroke or a 4-stroke dual-fuel engine. I will show you one slide of each as an example. I will not, I think, have time to go into all the details, but I will point out some that I think is important. And this image shows an example of a 2-stroke application. And this is a design which has been proven impractical in many vessel types over the years. The heart of the system is the tank connection space, which ironically isn't shown in this picture, but and we like to call it TCS. So the TCS is a gas-tight steel box. It's connected to the storage tank, and it's designed to withstand the cryogenic temperatures. And we designed the TCS to be able to handle any cryogenic spillage so that it doesn't create any hazard to other parts of the ship. And this is designed as a unit, one complete unit, handling all the tank control and the vaporization, meaning it can be manufactured locally and then shipped to the shipyard for installation as a complete unit. Then we also have the bunker station, which is part of our system design as well. And it's tailor-made for each vessel, both in the terms of the piping design, depending on the available sizes on board the vessel for the bunker station, but also in terms of processing design. So whether you want to fuel from trailers or from terminals or ship-to-ship bunkering. You can choose to, with our bunker station or our system, you can both fill the tank from bottom or from top, depending on what the current pressure and temperature is for the tank. And this is, in our system, completely controlled automatically by the control system. Since the two-stroke engine is a high-pressure consumer, we need to have pressure regulation between the tank and the engine. And when going with the Evolens engine, this solution will be an in-house unit, in-house designed unit called the PVU, the pump and vaporizer unit. So this is also within Evolens portfolio. And then for our complete system, we have the benefit of having standardized signal interface between the PVU control system and the control system for our FGSS. For this system, you also need the boil-off gas handling. And here you can see it as a boil-off gas compressor. So in case of having high tank pressure, the boil-off gas compressor will take out the gas and feed it to either auxiliary engines or gensets for usage. And one of the design developments made in our latest deliveries is to also include a boil-off gas compressor in parallel to the PVU. And this allows also the main engines to run on boil-off gas in situations when the gensets or auxiliary engines are not able to handle all of the boil-off gas produced. Then I will move forward to the four-stroke solution. And for the four-stroke engine, we can deliver two different configurations, either with or without the pump. So the configuration shown at the top is without the pump. And if the storage tank there is vacuum insulated tank, we like to call it as a cold converter system. So instead of having a pump, you will use the pressure buildup unit, which is a plate and shell heat exchanger, to drive the LNG from the tank to the engine. And a typical fuel gas supply system utilizes excess heat from the engine to warm up the glycol water system used for the vaporizer. But with our PBU-based solution, you can also utilize at least one additional heat stream on board. And I can probably say that we were also the first one to have this type of solution for the fuel gas supply system. And the benefit of it is that you will get improved reliability and lower maintenance cost because you will have no rotating equipment. And with the vacuum insulated tank, you will receive extremely low heat ingress, meaning you will not have any need of a boil-off gas handling system. However, it is restricted in sizing for the storage. So this solution can have up to around 500 cubic meters. For larger storage capacities, you need to go for this configuration with the pump. One development to mention for the then I will move forward. Because I also want to mention one development made by Yada, which is beneficial for the manufacturing, and that is the Smart Yada system. And I want to highlight that this is not an AI-generated picture. It exists in real life in their head office. I've seen it myself. It's very impressive. So their manufacturing workshops is very digitalized, meaning that with this smart system, which is developed specifically for Yara, they are able to do real-time monitoring of their manufacturing. And when manufacturing the fuel gas supply system, every step is important. And this means they can transform this complex process to transparent, actionable data assets. And with this system, they have improved their operational efficiency by 20% and reduced delivery cycles for the dual fuel systems by 15%. And one future plan for further development is to allow clients direct access to track their order progress. I also quickly want to mention the importance of service. So with the development over the years, with the systems being more, including more components and being more complex, the proper service has become very essential in ensuring a well-functioning system. With PrimeServe, we can perform diagnosis of the fuel gas system before any scheduled maintenance and dry docking. This means that we are able to ensure right spare parts available on time, reducing downtime and the cost. And to round up then, I also want to mention that for us it's very important with the knowledge sharing, because we need to share, so we think highly about knowledge sharing between now Cryo, PrimeServe and Yara, because it's vital for the future development of the fuel gas systems. Today I have been focusing on LNG, but we do see other systems coming our way, such as hydrogen and ammonia, with much stricter safety requirements. So then knowledge sharing is important. And before leaving the stage, I would also like to thank Ocean King for having us here, inviting us here. They are Yara's local representative here in Greece. And then I would like to thank you, the organizers, for having me.
Thank you very much, Sofia. Next in line is Mr. Minakis, Angelos Minakis, Business Development Manager of ABS. He's going to talk another view of the status of Net Zero Framework and what lies ahead.
Hello, good morning, ladies and gentlemen. Warm thank you to the organizers for having us here. I hope you can hear me loud and clear. So my presentation, I'll try to stick to the facts and keep it brief for you. It's about the Net Zero Framework. I'll start with the background, what happened during the last extraordinary session, and then the next steps forward. I'm sure many of you are familiar with the IMO greenhouse gas reduction strategy, the revised strategy. The strategy has set a target of 20% reduction on the total annual greenhouse gas emissions by 2030, striving for 30%. And for 2040, we have 70% as a target, striving for 80%. Based on IMO DCS data, we have a picture of what's going on since 2008. The indication from the data is that from 794 million tons in 2008 for CO2 equivalent emissions, we've gone to 810 in 2018. The use of fuel oil has dropped by 1% from 2022 to 2023, while the use of biofuels within the same period has grown by 73%. Still, of course, it's a low contribution of about 0.2% of the total fuel use. What GFI is all about, I think, can be summarized in this rather extensive slide. I'll just go briefly through it. GFI is a well-to-wake measure. It has the well-to-wake approach. Everything is, the GFI itself is expressed in grams of CO2 equivalent per megajoule, meaning that not only carbon dioxide is taken into consideration, but also other gases, greenhouse gases, such as methane and nitrous oxides. The basis of the measure is the 2008 average, which is 93.3 grams of CO2 equivalent, and then uses several tiers of compliance. On the red zone, the one on the top, we've got the Tier 2 compliance, where we're above even the direct compliance target. The purpose of it, in order to achieve compliance with it, there are three possible solutions. One is pooling with a vessel that is on the green area, on the light green area. The other one is use banked units from previous years. And the last one is just to purchase remedial units. The current proposal is for a price of $380 per ton of CO2 equivalent. Of course, on top of this, you will still have to pay the amount of $100 per ton for the Tier 1 compliance area. On the Tier 1 compliance area, the yellow shaded area, the only available option is to pay for remedial units. For those vessels that are below the base target GFI, there is a surplus. Now, they have the option of offsetting vessels on the red area, in Tier 2 compliance area, or banking for future years. Lastly, there's the dark green area, the shaded area, which is below the 19 grams of CO2 equivalent. And this is supposed to be an area for vessels that will get rewards, financial rewards, by the IMO Net Zero Fund. So far, no information is available on how this mechanism will work. In order to give an idea, a visual idea of what all this means, we've done a comparison of the three standards: the proposal of the GFI, as we know it now, the EU ETS, and the Fuel EU. We've taken as an example a vessel that consumes 30 tons of VLSFO per day in intra-EU voyages. We assume that the price of EUAs will be constant, 80 euros per ton for CO2 equivalent, and that the Fuel EU penalty is increased by 10% each year. So over the years, until 2035, we anticipate that EU ETS would be steady, because we have assumed a steady price for it, while IMO GFI penalty would double, and Fuel EU penalty would get 10 times as big as in 2028. We've also done a comparison among vessel type of fuel, several type of fuels. It's a penalty projection per metric ton. As you can see, none of the fuels that are mentioned in the table have a GFI lower than 19 grams per CO2 equivalent to qualify as a zero or near zero fuel. Now, during the latest extraordinary session of MEPC, consensus could not be reached. And the meeting was adjourned for another year in October 2026 due to institutional division, heightened tensions and fragmentation, and need for broader consensus. We've included a table of the votes. Among others, yes to adjourn the vote for next year was Liberia, Panama, USA, China, Russia, Bahamas, and Saudi Arabia, the flag state that brought this proposal. Among the countries that voted no and wanted an immediate adoption of a net zero framework were most of the EU member states, Marshall Islands, Singapore, and the UK. It was Greece and Cyprus that abstained from the voting. Now, the key points of contention are the acceptance procedure itself, whether it should be tacit or explicit. It is the regulatory fragmentation, meaning that a decision must be made whether other schemes will be allowed or not, or such as the European Fuel EU. And then the impact on the maritime industry. The impact would be increased compliance costs for ship owners and charterers, administrative burdens, and possible financial strain imposed on nations. Now, as the next steps forward, IMO will need to focus on re-engaging and building consensus among all member states. Adoption of the net zero framework will be discussed in the next extraordinary session in October 2026. An intersessional working group has already taken place in late October 2025 and focused on preparations for the entry into force of the IMO net zero framework, because there's a lot of things that need to be clarified on this one. Discussing topics like the life cycle assessment of marine fuels, developing a quantitative risk-based approach to indirect land use change emissions, and exploring policy signals to promote e-fuels. Of course, IMO will also continue to work on the safety perspective of using fuels as alternative fuels. The subcommittee on carriage of cargoes and containers will work within 2026 on guidelines for ammonia, hydrogen, methanol, low flashpoint fuel oils, fuel cells, and carbon capture systems. Last but not least, new ECA areas for the Canadian Arctic, the Norwegian, Northeast Atlantic waters are expected to be adopted during the next scheduled MEPC 84, in April 2026.
1 minute, please.
That's all for me. Thank you very much.
Thank you very much, Mr. Minakis, and for your very prompt delivery of your speech. Last but not least is Mr. Vasilis Tsatsitalidis from ERMAFest regarding energy-saving technologies. He's going to talk to us about, that's a very good subject, a realistic approach to decarbonization and compliance in times of uncertainty. Vasilis, you have the floor.
Yes, thank you. I know the time is limited, so I'll go straight through it. I'll have to apologize in advance for getting too technical at some points. So I'm not going to discuss about the regulations. The colleagues have already said that from the classes. IMO has been adjourned, and now what? Well, right now we have a trajectory to reduce emissions. EU ETS, Fuel EU, CII, XI, everything is still in effect. Also, the fuel prices are still high. So everybody is trying to find ways around those which they already exist. So everybody is looking into alternative systems, conventional ESDs, paints to reduce friction or other ways to reduce friction. They look into the operational ways, electrification, alternative fuels, of course, and those who are a bit more risky, air lubrication, wind assistance, and carbon capture. There is a lot of future in all of those. Time will tell. ERMAFest and the ERMATEC group right now, we have a wide ecosystem of technologies ranging from the electric side all the way to data and air lubrication, carbon capture, and the energy-saving devices which I represent right now. So the quick pitch would be, okay, so you have a vessel. If you install BCF, you will get something like 2.5% of efficiency. If you install a duct, you will get another 4. If you install the fins, you will get another 1. If you alter your propeller, like trimming or something like that, you get something like 3 more, so you have a total of 8%. And if you also add low friction paint, you have something like 12%, end of story. But things are not that simple. So as we say, the problem is non-linear, which means things are not that simple. So here's the point, I'm getting technical. So this is the open water diagram for a propeller. For the non-naval architects, a very quick introduction. These are non-dimensional curves we produce for each propeller we have, and it represents the performance of the propeller for different speed and different RPM. Very quick rule of thumb is that the more you go to the right, the faster you go for the same RPM. And what we focus right now, and the point I'm going to show is the bell curve you see on top, which is the efficiency curve. So on the efficiency curve, over here we have the blue line, which was the original efficiency of the propeller, and the black line is the efficiency of the propeller with a PBCF installed, or our FlexCap. Normally, the operational point is where you see the circle right now. And if we do what we promise and we optimize for the operational point, then that's the point you will have the highest increase of efficiency. Now, if you stack on top of that another system without designing together, you will be pushed slightly to the right. So if you are very careful with the curves, you can see that we have lost a bit of efficiency if we just do that. And if we also add low friction in the game, then we go way further, and the gains are getting even smaller. And if we, let's say, have a really good wind assistance system and we have something like 20–30% of extra push, then we're pushed all the way to the right side, and we practically get the same efficiency, but with an unloaded propeller and the efficiency dropping very fast, and probably problems like overspeed to the engine, or I don't know what else you're going to have. Also, for the ducts, if you have a pre-swirl, then we have problems with power margin. So, CFD are nice and fancy and colorful, but we need to do actually the well-known spiral of design. So, starting from the resistance of the vessel, we go to the open water of the propeller, then we optimize, and then we check the wake, knowing the propeller that we have, to get the interactions. After we optimize for the duct, we go to optimize for the fins, and then check, again, the propeller. And if everything is okay, then we have our final ship. So going back to the previous slide, the new propeller, you can see in the background it has changed a bit. In the green circle now, you have the area of the highest efficiency over there. I mean, also the maximum gains, we have them also over there. So we can take that into account as well. Now, if we have the time, I will get to a couple of extra of key points on extra systems. So the Ermatec group also has a strategic partnership with Armada, so we co-develop now an air lubrication system. And also in such a system, okay, we have the friction reduction as discussed, but we also need to optimize in order to avoid having air in the propeller. Or we need to make sure that we have a wide distribution under the bottom, which is not necessarily the case in most of cases. And last but not least, considering wind assistance, again, I will suppose that we have an ideal system that works very fine and will give you the maximum of efficiency as everybody promises. And in an ideal wind, which is from the side, you will have the maximum thrust, but this will create also a leeway force. And right now, all you have to resist to that is just the sideways resistance of the vessel, which is not too much. And if you can see the vectors, you can understand that there is a torque that tends to turn the vessel, so you lose your heading, and you need a lot of rudder action in order to compensate for that. So in order to have this properly and make it work, you practically need a dagger board or a keel system that will resist to that. And if done properly, it will also give you some extra thrust and some maneuverability as a bonus. So last point, going back to the open water propeller curves. As I said before, this is the original design point. If you push the vessel a lot, and this is like 40% right now. I'm using this number because it has been discussed in some previous presentations. Some people promised something like that. If you push the vessel that much, then you get into a region that the propeller is unloading. And right now, the only solutions for that is either have a controllable pitch propeller. A more futuristic thing would be to have a different material that the propeller changes its geometry. But right now, to be honest, everybody is just keeping the assistance at a very low point. So the key takeaways for us right now is that, okay, the future is unknown, but energy reduction remains a must. We already have the technologies in place, and we develop more. The savings can exceed 10, 15%, depending on the vessel, obviously, but only if systems are designed together. And that's a very serious point. Wind assistance and air lubrication are very promising, but they are not as mature as we would like them to be. But to be honest, they are the only conventional solutions that we already have in place. So a bit of a teaser from our side. We will launch in some months from now. We don't have the products ready yet either. But this is also our proposal. And I think we are in time.
Thank you very much, Vasilis. And I want to thank all the speakers for their very well-prepared contributions. Now, I would like to make a very quick recap of what we have heard. One point is, should shipping be the target of decarbonization? That's a question. And possibly we have gone a bit too fast, too far. That's a question. IMO cannot control the supply of fuels. It is the governments that control the supply of fuels. And I personally believe that IMO has made, in the latest regulation, a strategic mistake in condemning the use of LNG as a fuel, as even a transitional fuel for the next years, whereas in reality, the theoretically stated available fuels, alternative fuels, do not exist. In reality, today we have 1.5 fuel. The one is the fuel oil, and the half is LNG. There is nothing else. And whoever tells you that there are alternative fuels, I think it's just not lying, but misinforming you. Having said that, I would like to ask the learned colleagues here one, let's say, question. Is IMO really in the lead? What do you consider a possible change to the regulation that will enable passing next year, next October, because I think that we all know that as the regulation stands today, this cannot be done. And one more question is, do you think there is a realistic game-changer technology that could enable enable compliance for new or existing ships? Mr. Kourgoudis.
Yes. I would like to give you a short answer on that. When initially I was presented the net zero framework, I believe that the industry was quite enthusiastic because we would like to have one regulation that will replace all the national regulations, and it will be something very good for the environment and also for the shipping. After certain weeks and months, and we start having some scenarios to see exactly what the regulation is, we realize, first of all, that the cost was out of question, and that all fuels had, the existing fuels, had exactly the same performance, even a very strange result. For instance, the HFO, the heavy fuel oil, that was replaced for environmental reasons for the very low, was cheaper in the penalties and in the price than VLSFO, and was also the best solution for everything. LNG also was a non-compliant fuel, and bio was a compliant fuel only for very few years, the first 3 years. So then we start thinking, but is this regulation, since the other fuels are not available? And as you know, we had big discussion on how to proceed. Then we had Europe that did not withdraw the local regulation, so we said, that's not a global. Then we had the US came to say that we will not apply the regulation, and we said, okay, then we have a regional regulation, one more regional regulation that will be applied probably in China and Europe, but will not be applied in the whole world. And also that we have this problem with the way that the regulation is set, that finally who had invested in a better ship, LNG or bio or whatever, will have a penalty higher than the conventional, the old conventional shipping with the scrubber. And it was, we tried to see if the regulation pass, what kind of changes we can do to make, at least to correct this flow of the regulation, to supply fuels that we will not consider. And then we realized that whatever is the figure that you could put in the penalties, the regulation remained unchanged. So even if instead of 100, you put 10, instead of 350, you put 500, or you do it the opposite. You put instead of 350, 100, and instead of 100, 200. Doesn't change, and will not change because actually the regulation has a target which is 0. All the existing fuels are over 70 and 80 over there, 90. So when you have 0, the difference between the fuels is marginal, 5% difference one fuel from the other. If you have the target very close to the 70, the fuel which is at 70, it's already compliant, and the fuel which is at 80 has a huge difference. Even if you have a difference of 10%, let's say we put the target at 60 and 70 is 10 over, 80 is 20 over. Make the game more fair, because we are coming to be concentrated of what we have and what are the difference. But if you put the target far away in the space, in the moon, then the difference between Athens and Thessaloniki from the moon is exactly the same. So that was the flow of the regulation. And actually the regulation came as a consensus with different numbers. The trajectory was not studied properly. It was a regulation proposed by Singapore, trying to combine regulations, technical regulations that were proposed by Japan and by China, and said, okay, we will make, also Singapore had its own, we will make one that we will have them all together. And everybody said, okay. But what will be the trajectory? Okay, someone said here, there, there. And what will be the penalties? Someone will say 20 and some other will say 800. At the end, they found the figure, and then when we show the result,
they say that a camel is a horse designed by a committee. And, and I think this regulation is sort of a camel. But the question remains, is there something that can be done for this regulation to be adjusted
for
and
this
be adopted
now that the
next
regulation
year?
is back to the scrap? If we wish to continue in that route with the penalties, then we should have a new trajectory which will be closer to the fuels that we have. And at the point that we start having a substantial percentage of alternative fuels and a kind of infrastructure to supply ships with these fuels, then we can put the target lower and lower. But at the moment, if you put the target lower, then that doesn't make any sense, because everything is out of question and everything is the same, and the cheapest is always the better. If we don't want to have penalties, because the US seems that it is poised that do not accept any penalties, do not accept any increase of the transportation cost at this moment, because they have their own tariffs. So if they wish to increase the transportation cost, they put tariffs only on what they import. They don't want to have tariffs also on what they export. Then we have no other option than going to technical proposals like CII and EEXI. EEXI and CII are under revision now. I will not support the EEXI, because I don't think that the solution is actually to have an existing ship and every 2 or 3 years to put a new limit and new limit and new limit, because that's technically is not possible. But with CII, we have a still huge margin. This is operational measure. The ship, of course, a better ship will have advantage in terms of competition, but what CII is doing is limiting the amount of fuel, the emissions, and actually the amount of fuel for a specific voyage. You want to travel from New York to Rotterdam, and you have a ship of this capacity. Maximum amount of fuel that you have to burn is $500. You can do the same voyage with 300, and you can do it with 1,000. So if we have a limit there, of course the ship which is efficient does not have any implication, will run, and with 300 tons we will do the voyage. The ships that are older and they consume more, they have to reduce speed and they have to consume less, and of course they will have a commercial disadvantage.
Thank you very much.
If I have the opportunity to actually answer or try and answer your questions directly and to the point, I think it's the IMO really back in the lead. The IMO has been dealt a blow. I mean, there's no question about this. We shouldn't be behind our fingers. The IMO, as an organization, has been dealt a very serious blow. And unless it moves out of politics, because the IMO is not and has never been intended to be a global government, it's a room where representatives, usually technical, from 176 countries gather to discuss big issues. When you try to tackle the biggest issue in our lifetime, namely climate change, it's not surprising that the IMO failed. Let's not mince our words, it failed. But it's an impossible issue to tackle. So what can it do? It can actually listen to the industry. And I put the points in my slide, so I will not repeat them, just summarize very quickly. Number one, well-to-wake, not appropriate for shipping. We don't control fuels. Why should we pay for emissions during the production of fuels? So shipping should only be charged for tank-to-wake. The trajectories should become less steep. The concept of a global fuel standard, with respect to my colleague to my left here, is probably the most sensible one. However, the values need to be adjusted in a more realistic manner. You cannot make LNG an outlaw fuel by 2028. It's just, there is no other available fuel. Therefore, that nonsense should be stopped instantly. And finally, there should be a definitive assurance from regional regulators that as soon as a global one is put into force, they will cease to exist at the same time. No double taxation.
Absolutely, thank you very much. And I think one idea that should be very seriously considered, and taking the example of the car industry, for example, into account, is the adoption of the greater adoption of electricity in the ships, from let's say making the ship fully electric or making it partly electric for port operations, or there is lots of ideas that we can take from other industries where they have successfully tackled the project of decarbonization, not with fantastic fuels coming from the moon or the Mars. And I think this concludes.
Any questions from the floor? Anybody wants to ask a question? Go ahead. There is a microphone next to you.
Yes, hello.
State your name, please,
yes.
and affiliation.
Yes, my name is Dimitris Nanouris from OTC Flow, fuel EU broker. I have a question for Mr. Minakis. You mentioned earlier a price of $380 per ton of CO2. Can you please remind me what was this exactly? Was this like the price to enter a pool, to buy surplus, just for my understanding? Thank you.
That's the price of the remedial unit when you fall in Tier 2 compliance, in the red shaded area.
Okay, so not related to pooling and...
No. Pooling is one choice. Paying the remedial units, as they call it, is another one. It's totally... Yeah.
Thanks so much.
Any other questions? Yes, go ahead.
Good morning. My name is Panayota Ioanna Vounanioti. I'm a college student in National Kapodistrian University of Athens Department of Port and Shipping Management. And I wanted to ask, since nuclear propulsion promises zero-emission operation and long refueling cycles, what incentives or guarantees would convince ship owners to invest in nuclear-powered vessels, given the high initial costs and uncertainty around global acceptance?
What incentives? Okay, first of all, we need to see this technology more mature than it is now. So, because it's different to have something in theory and to have something in practice. Because we have nuclear ships and nuclear submarines long time ago. But for different, let's say, use. We have to consider when we have, you build a vessel, you build it because you want to use it commercially, and at the end of the day, you also make some money. So it's the same also why this IMO, let's say, SGF has a lot of issues, because the shipping becomes not sustainable. So when something is not sustainable, it's not good for the ship owner, it's not good for the end user that we will receive a product that will be extremely expensive. As there are two completely different opinions for nuclear. I'm sure there are some people down, and I know some people that they say they're fanatic, they say yes, it's the only solution, and there are some others say no, it's impossible. I think we need too much time to persuade the people that this is something that is safe. Also, all of us here who have become mechanical engineers, electrical, electronic, and now we have to become nuclear engineers. We don't have so much knowledge, all of us, me neither. So we just see what's happening. We see that even Bill Gates is investing in this, and we might see in the future, but I don't see it very near. And regarding the waste, is something that I really don't know, but I agree with Mr. Kourkoudis that there is something. If we have 30,000 of ships with a nuclear battery, some people say, what all these waste will happen, and when is going to be disposed? So it's a big question. So it's, we'll have to see maybe after 20 years how this will happen. Thank you.
Very, very briefly, if I can present the other side, I'm not a fanatic for nuclear energy, but my background is on military naval design. So I have to say that we have 73 years of accident-free experience on both surface and submarine operation in the US and the Royal Navy of the UK. Please note, I don't mention the Russian Navy. I know there have been incidents. I am talking about two navies with a very strict training regime. No Royal Navy officer gets on board a nuclear-powered vessel before he or she has completed a minimum of 6 years training. That will be a problem for a commercial vessel. Trying to find seafarers that will spend 6 years training before they go to operate. In terms of the technology is not mature, but it exists. Why is it not mature? Because we don't propose to use the nuclear power plants used on an aircraft carrier or a nuclear missile submarine. They will be a lot smaller, and they will not be as radioactive as people think. A molten salt reactor operating with thorium as the fuel, which reacts through electrolysis and produces a uranium isotope that is 1/10 of the radiation of the isotopes used on land-based nuclear power plants, or indeed on surface and submarines in the military field, will not be that dangerous. Public acceptance will be an issue. So my suggestion, drop the term nuclear, let's find a different word for it. And finally, trying to persuade insurers will be an even bigger problem. But the technology is not an issue. The politics, I believe, are the issue, not the technology.
Just to add something, maybe the solution is to have nuclear on land to produce green fuels, because nuclear power is the only way that we can produce e-fuels, green fuels in big amounts. So maybe nuclear on land, and we see in China they built 25 nuclear factories. In Arabic Emirates, they produce, one of the producers of fuel, they built now a nuclear factory, so maybe they know something.
Okay. First, we should understand that nuclear fuels at the moment is under proliferation. It is not something that you can go and you can buy. And there is a reason that it is prohibited, actually, the market of these fuels. There are very few companies that they produce this kind of fuels, Urano here in Europe, and all of them are under one umbrella. So it is not something that a private company will go by itself and they start buying nuclear. The technology, we are talking about the new one with the small modular reactors. Yes, it is smaller. Yes, will produce less fuel, but still it's a nuclear fuel which is produced, and it's a nuclear fuel which is used, and nuclear waste which is produced. doesn't make any difference if we are talking about a feast. This can produce, can make a disaster if it is out of control and if it is thrown into a metro station. And you can't control for centuries this kind of waste. So I'm not talking about accidents. Let's hope that we have 0 to 1 million accidents. We're talking about many, many units. And as today there are people that they are dropping other things, definitely if this goes to the wrong direction, you will have, we're going to have problems. This is something that it is added. Still today we have a perfect control, and the radioactivity is growing up everywhere. When we had the first internal combustion engines 100 years ago, nobody was thinking that we were going to have this problem. It was something that out of mind, that the smoke, that it is absorbed by the trees, will have the problem we have today. Thank you.
Thank you very much. It's time to make our break. We will break until 12 o'clock. The break is sponsored by ABS, and we'll see you back at 12 o'clock. Thank you for all the speakers and all the audience. Our second session is Technology Innovations for Sustainability, and I invite Mr. Haris Yantzikis, Technical Manager of Arcadia Ship Management Company, to moderate the session.
Thank you, Mr. Chairman, and thank you, Naftiliaki, for giving me the opportunity to be a moderator again. While on the first session we had the speakers telling us why IMO failed to move forward with net zero framework, we still have, as owners and operators, we still have to limit our carbon footprint and use existing technology to do that. So the next 7 presentations will be about this issue, how we can limit our fuel consumption and how we can be a better operator. First speaker will be Mr. Stavros Hadjigrigoris, Advanced Engineering Services and Zodiac Maritime, and he's going to talk to us about experience with alternative fuels that are available and have been used, not the ones that, the exotic ones that we've heard of. Stavros, the floor is yours, 10 minutes.
Thank you.
Thank you.
Καλό μεσημέρι. I don't know how they say it in English. Let's say good afternoon. Thank you for the invitation. Thank you, guys, for helping me with this presentation. I don't know why, but I was only given 10 minutes instead of 15 for the other speakers. I hope that I will have 5 more minutes for questions. I wrote this presentation 2 times. One, I realized that it was very technical, and I believe the audience here is not 100% technical, and then I rewrote it to include some economics in the presentation. Γιατί πάρω αυτό. Okay. So this has been discussed already, no need to repeat anything about this. This is the trajectory to 2050, has been discussed already. My personal view about what happened in IMO was that in a way we are also responsible for this. We delayed the discussions too much, and IMO had to rush things and come and propose solutions that were not 100% ready. But this is life. If we talk about biofuels, biofuels is something that a lot of operators are using today. It's supposed to be a zero carbon fuel. We don't biofuel up to B30 we can use without asking for a special permission from the flag state. If we say B30, keep in your mind that the reduction in carbon in emissions is not 30%, as it should be, because the well-to-wake signature of biofuels is a bit worse than HFO, and also the efficiency of the engines are a little slower. So if we get B30, keep in your mind that we will have to expect that the EU ETS penalty or whatever will be not 30% less, but about 22-23% less. Engines can operate with biofuels. As I said, the efficiency is a little slower. Some minor problem with cylinder units, and the use of biofuels is getting higher and higher and higher. This is how the cost of B30 is projected to year 2040. Keep in your mind the number of $15,000 per metric ton in equivalent energy terms. Talking about the technical problems, and I will rush through it. The first generation of dual fuel engines, except biofuel, and at that time biofuel was still not very well known, is high pressure LNG. We had a pressure of 300 bar in the engine room. A lot of people were saying, the ship will explode 5 minutes after delivery. Did not happen. As what did not happen in the past was cracks in the double hull tankers. Everybody was saying, we give you 100 miles to go and then the ship will explode. My personal view is that safety problems can be solved. There are technical solutions to solve technical problems. There has been a development of the engines from Mark I to Mark II. The big advantage of the Mark II engines is that if you have a cylinder failing on gas, this cylinder can work on fuel, and you don't have to switch the whole engine from gas to fuel, and this is a big advantage. I think it's amazing, but maybe O-rings is a separate science, but one of the main problems that we have with gas engines is failures of O-rings. Sealing oil leaks, again O-rings. And one of the issues that we have seen, and it has not been 100% explained by the engine makers, is increased wear of piston rings. I don't know why, but class societies have accepted to test the engines in the shop test, not at 110%, as it was the norm before. They say 100%. If you go above 100%, most probably you will have a failure even during the shop test. This is the LNG price as projected to 2040, so it's close to $2,000 per metric ton, equivalent again energy terms. That means that it will be more expensive than biofuels if the prices are kept as they are today, the price to buy. Low pressure LNG engines, a lot of problems in the beginning. That was basically liner overheating, and they did not have the suitable lube oil to use with the engines. And there have been a lot of improvements. The main reason for the improvement was to reduce the methane slip. If we calculate the cost of fuel for low-pressure engines, you will see that it is higher than the cost of fuel for the high-pressure engines, and the main reason for this is methane slip. And of course, for methane slip, now they have a second generation of low-pressure engines that has been promised that it will perform better, but in any case, not at the same level as the high-pressure engines. And this is, again, the same comparison. LPG engines, a lot of people said LPG may be the solution, despite the fact that LPG is heavier than air, i.e. more dangerous than LNG. There have been about 200 engines now in operation and on order, still teething problems with the high-pressure pipes, with air intrusion in the system. And this is a common problem for LNG and LPG engines. What we do with the fuel nozzles. They continue to be cracking, both the main fuel nozzles and the pilot fuel nozzles.
2 minutes, Stavro.
Whole 2 minutes? Thank you.
2 minutes for closing.
Okay, I have a nice joke, but it's 3 minutes. Okay, the drawing that you can see at the end with the green cap is the solution that is being proposed now, to use a cap so the nozzle is not overheating. Methanol, again, with their problems. If you ask Maersk, they say methanol is the perfect fuel. They have 17 ships with methanol. They only operate one with green methanol and one with gray methanol. And from what we hear in the market, there are problems. And this is the cost of gray methanol, lower than biofuel and lower than LNG. And this is a comparison of the cost of fuels, of all fuels to 2040. A number of dual fuel engines in operation and on order. Everlens is leading, basically because of the high pressure engines. 1,800 engines in operation and on order. And WinGD is following, having the lead for the for the ammonia engines. Ammonia is 32 engines on order for WinGD and only 4 for Everlens. And this is something that we thought to do quite quickly. If you look at the 3 yellow columns, this is the cost of the GFI and the fuel EU in relation to the cost of the cargo. Not something very high, despite the fact that we are all screaming. This is how the cost of HFO is projected. And these are my conclusions. Sorry for my extra minute. There is no way that we will have a new technology without problems. We were not used to problems in the past, but now we talk about new technology and we have problems. What is happening today is we have a number of new engines and engine versions introduced into the market without sufficient testing. Trying to catch the market, they don't test the engines. They say you finished your shop test, and then 2,000 hours later they say, this has not been tested. Of course, the engine that will prevail will depend on the infrastructure for the fuel that this engine is going to use. And what I don't like between engine designers and glass societies is the fight to see who will get the lion's share for a specific technology, which in my view is not helping the market. It's better to work together than each one of us to set a target and say, this is I am ammonia, the other guy is methanol. Let's see what will happen. Thank you very much.
Thank you, Stavro, for sharing your experience with us. Our next speaker will be Mr. Simon Ma. He is the product manager of medium and low speed division at Acceleron, and he's going to talk about the latest axial turbocharger series development. 15 minutes, Mr. Ma. Thank you.
Okay, good afternoon, ladies and gentlemen. As mentioned many times, we still have many uncertainties concerning the regulatory framework, as well as technical and operational measures needed to support sustainability targets. To handle such uncertainties, having greater flexibility is often mentioned for building resilience and adapting to changing circumstances. And more efficiency becomes increasingly important in the face of immediate reporting and rating requirements, limited availability of alternative fuels in the short term, and to support their uptake in the longer term. It is against this backdrop of needing greater flexibility and more efficiency, I have the honor to present to you today the status of Acceleron's latest turbocharger development. Following the success of our current A100 and A200L, the X300L is our next generation of axial turbochargers for two-stroke engines. This time combining new technology advancements, field-proven concepts, and a rigorous qualification program, the X300L turbocharger series will continue to deliver high performance, and in addition, enable innovative service solutions and more opportunities for tangible fuel savings. Rest assured, the X300L is also alternative fuel ready, based on our close collaboration with engine designers, latest literature studies, and laboratory investigations. Nevertheless, we will of course also closely monitor our front runners in the field. Throughout the development, we were guided by the principle of simplification. By simplification, I define as maximizing commonality of components, further standardizing interfaces, increasing modularity, as well as minimizing variance and complexity. We pursued simplification for a few reasons. One is to reduce supply chain complexity, but also to create the design space that will allow us to consider more than just engine requirements of today. We went further and set our own internal targets for pressure ratio and power density. The results of this can be clearly seen in the turbine and compressor development and will allow us to introduce as a first step two frame sizes, the X365L and the X370L. We are also introducing new design features like a cartridge concept and the twin concept. In doing so, we will unlock innovative service solutions such as cartridge pooling and create more opportunities for tangible fuel savings via turbocharger cutout on vessels with two-stroke main engines. Bringing these objectives down to the component level, of critical importance is the rotor. Specifically, the advanced axial turbine stage has been designed allowing for improved efficiency levels at high turbine pressure ratios, while at the same time significantly reducing high cycle fatigue excitation. We have also increased specific volume flow capacity. An 11% increase is shown here for X300L's second highest throat area versus our current A200L's maximum possible. Simplification is achieved with only one turbine stage shared across all compressor stages, and the qualification of performance and reliability have been completed, with the results exceeding our expectations. For the compressor stages, we plan to increase specific volume flow capacity as well, on the right by as much as 20% compared to our A200L. Also to increase pressure ratio, now reaching above 5, to enable engine builders in increasing mean effective pressure. The robustness of these compressor maps will be physically verified in our test rig facilities in Baden, Switzerland. And in terms of simplification, all compressor stages fit into a single casing and share the same shaft connection. Now, with increasing modularity in mind, and the additional design space granted from our efforts towards simplification, we are introducing for the X300L turbocharger series an exchangeable cartridge containing all rotating components. Here you can see it in the middle of the image on the right. It includes the bearing casing as well as the compressor and turbine wheels. With this cartridge, further dismantling to isolate the rotor as you would normally perform during a major service event is not needed. The extraction of the cartridge is done from the cold side without touching hot gas inlet and outlet casings as well as both feet. And traditional access to the rotating parts from the hot side remains, with the nozzle ring and covering accessible from both sides. Knowing that space and time spent in the engine room can be a premium, we've made design and process measures to ensure the exchange of the cartridge is as efficient as possible, such as all casing connections are axially accessible within the box volume of the turbocharger after dismantling the air outlet, and the cartridge, including its packaging, are designed to fit on a standard shipping pallet. We also made significant efforts to receive feedback from our service engineers, leveraging their field experience from exchanging similar cartridges that we've applied in our turbochargers on four-stroke engines. This ensures we have a robust design and a safe methodology for the exchange of the X300L cartridge on two-stroke engines. For added flexibility, the extraction and installation can be done by either Accelleron service engineers or the vessel's trained crew. Here on the right is a basic representation of a vessel dry docking schedule. With a fast exchange of the cartridge, ship operators gain flexibility with more opportunities for major service events at, for example, port stay. Having less dependence on a dry docking schedule and performing service when due, this added flexibility can also result in more optimal usage of components and potentially less service events over the lifetime of a vessel. Another example of an innovative service solution. Building upon the exchangeable cartridge and major service events at port stay is what we call cartridge pooling. By creating a pool of these cartridges, both refurbished and new, together with Accelleron's global service network and digital monitoring offerings such as Turbo Insights, a ship operator gains the highest availability of parts with minimal downtime. By way of a cartridge of the same specification waiting at the port or on the vessel, ready for the next major service event. The matured cartridge is then taken off board and transported to an Accelleron service station for refurbishment. So again, in summary, with less dependence on the dry docking schedule, you have additional flexibility and optimized usage of components from major service events at port stay. Optimal turbocharger performance from digital monitoring and with the highest availability of parts from cartridge pooling. Moving on to the twin concept. Here we take advantage of the increased power density and high efficiency rotor and bring together the two frame sizes in development, the X365L and X370L, in unconventional parallel pairings that we call twin. We can use twin to replace the larger frame sizes in our low-speed turbocharger portfolio with smaller and lighter ones. In this example on the right, where an A275L is specified, we could also specify a twin X365L. With the addition of twin, we cover the rest of our portfolio, as shown here, with either twin X365Ls, a twin X365L, an X370L, or twin X370Ls. By doing so, the benefits of the fast exchangeable cartridge and innovative service solutions are extended across this engine power range. With only two frame sizes, we are able to maximize the opportunities for cartridge exchange at port stay. Where such opportunities for larger frame sizes, we currently consider limited due to space and weight requirements that can lead to challenges with parts handling and job duration. Also, with only two frame sizes, we simplify the cartridge pooling example just mentioned, where additional frame sizes would add more specifications and therefore complexity to managing a pool of cartridges. There are other advantages that we have seen. with the twin concept, a potential for an optimized on-engine arrangement when we replace larger turbochargers with smaller and lighter ones. Here you see an optimization of the high-pressure SCR piping and accessibility to the top platform. Also expected is an improved flow distribution at the cooler inlet with less overall weight of the welded structures. In this case, with the addition of the turbocharger of the twin, you would then also have the option for turbocharger cutout. Turbocharger cutout is when you cut off the inlet gas flow to the turbine and compressor outlet to avoid backflow at engine part load. With higher scavenging air pressure, one can achieve higher engine efficiency and lower specific fuel consumption. There is also the possibility to switch off electrically powered auxiliary blowers and reduce energy consumption. Now, we appreciate this is not a new concept. However, it's a field-proven technology that can achieve tangible fuel savings for further uptake when looking forward, as efficiency and fuel consumption become more important. The running hours of the turbocharger involved in the cutout operation will obviously be lower compared to the others on the engine. Different utilization leading to different maintenance needs. This is where the fast exchangeable cartridge of the X300L can further support the uptake of turbocharger cutout by enabling the ship operator to cater for the individual maintenance needs of each turbocharger and performing service when due, independent of the dry docking schedule. Accelerant's X300L is equipped with external sealing air connection, bidirectional radial bearings, and qualified for the cutout operation. As further evidence of our support for turbocharger cutout, Accelerant has developed its proprietary FITS2 system. The benefits of turbocharger cutout can be extended to the existing fleet. The cut-in and cut-out valve operation the cut-out and cut-in operation of the gas inlet and air outlet valves is no longer a manual operation as seen in the past. Rather, it can be fully automated via an in-house developed control unit. This optimizes engine fuel consumption at part load, while at the same time having the flexibility to go to full engine output immediately. Additional features are implemented to ensure fail-safe operation and to prevent the excessive deposit accumulation near the valve area. Currently, we are in the qualification phase of our development and iterating on design details as we proceed. The qualification process covers operational reliability, safety, and conformity, with over 20 tests that must be completed by hardware testing, numerical, and analytical assessment. Here on the right are just a couple of images of our efforts to date, as well as an overview of the test rig setup. So in closing, with Accelerant's next generation axial turbocharger series, X300L, based on high performance components, increased power density, integrated exchangeable cartridge, and twin, we can enable innovative service solutions to achieve optimal turbocharger performance, optimal usage of components, and with the highest availability of parts. We can also further support and create more opportunities for tangible fuel savings via turbocharger cutout. Thank you for your attention.
Thank you very much, Mr. Ma. Our next speaker will be Trevor Solomon. He is Business Development Manager for Sustainability and Fouling Control of Akzo Nobel International Marine Coatings. His presentation will be Interslick, Pioneering Performance and Sustainability in Fouling Control, Shaping the Future at Sea. 15 minutes, Trevor.
Thank you. Good afternoon, everybody, and thank you for inviting me to speak this afternoon. It'll be a pleasure to be back here. So, the conversations this morning were really enlightening in terms of the zero, not zero discussions, but as was introduced in this session, it's all about what we can do with our existing technologies in order to be able to maximize the benefits that we can achieve from that. So we've just heard about the supercharger there, the turbocharging in terms of efficiency of the engines. I'm going to talk about the outside of the ship, the hull. So I will go over that. But first, I just want a very brief look at the legislations on the basis that we have talked a lot about the net zero, but There's also the other side of the legislation where it's impacting on the materials we can use. So when we look at the legislation for fouling control, or indeed decision-making on fouling control, we can see there's been a huge increase in legislation over the years. So the plot there is looking at the last 25 years and projected through to the next 5 years. In terms of legislation that's been enforced, put in place, that influences what we can put in our coatings, as well as the choices that you guys, as ship owners and operators, need to make. The red line is quite telling. That's, if you actually do the regression on that, that's an exponential line. So that would indicate things are increasing more rapidly. Now, will this continue in this way? Well, I don't think it will. I think the level of legislation that's in place is already very high. But what we will see is the legislation will be tightening. So a really good example of that is the IMO AFS Convention, the Anti-Fouling Systems Convention. It was agreed in 2003, went into force in 2008. People around the room will probably know that as the tin ban. Well, that was reenacted effectively in 2021 with the addition of sibutramine to that list of prohibited substances. So it's not necessarily new legislation, it's enhancement and tightening of the existing legislation that will drive things going forward. Now, this is really important because the fouling control, what we put on the outside of a ship, is very important for the efficiency of the vessels. If we are limited to what we can do, then we need to look for new solutions, new alternatives, ways of doing it. So if we look at that legislation in three key areas, decarbonisation, we've talked about it a lot, but decarbonisation in terms of what we can do for fouling control, where's this driving our technology? It's about efficiency. It's about what we can do in terms of the fouling control coatings in order to improve or maintain the efficiency of the underwater hull. Slightly different from the fuel aspect. When we talk about the zero and net zero fuels, the costs that Stavros was talking about just there, they are more expensive. So as we do transition to alternative fuels, efficiency of the ship's hull will become even more important because you're going to be burning more fuel, lower energy density at a much higher cost. So the efficiency of the hull mustn't be forgotten. And it's not just fouling control, it's the anti-corrosives in order to protect the assets, prevent the steel from corroding, because it's all about the roughness of the outer shell. Biosecurity. Now, it's not been touched on today because it's all been about decarbonisation, but there's a big move within the IMO at the moment for creating a biosecurity convention, looking at the translocation of invasive species. Now, we've already had the Ballast Water Convention. The other vector of transfer of invasive species is on the outer shell of a ship, in terms of the niche areas, the propellers, the rudders. And this is a major topic of discussion point going forward. That will result in more in-water inspections, more in-water cleaning, which means for fouling control, our coatings need to be compatible with these systems. Also importantly, the locations where we can actually carry out underwater cleaning, in-water cleaning are limited. So they need to increase. So the areas where this happens, which means that testing is going to have to be done on the in-water cleaning systems and more homogenization in terms of the capabilities of the in-water cleaning companies. And lastly, an association with that is the pollution. So in-water cleaning generates bio waste, so that needs to be collected and treated in most instances. But also what's coming off our coatings. So traditionally, the way of controlling fouling growth is the use of biocides, and biocides are slowly being taken away from our concept of being able what we can actually use. Biocides is delivering something to the environment, so we need to be looking at ways in order to reduce and eliminate that area. But also, there's other things on the horizon. Microplastics is a big topic that we have in fouling control. How do fouling control coatings contribute to the microplastic problems that are evolving? So all of these lead to, from my company's perspective, is to generate more high-performance coatings in order to ensure the efficiency of the ship. and coatings that are compatible with cleaning. This is going to be an essential requirement. Biocide free, the legislation is moving towards this direction. And also microplastic free, another contaminant free. The good news is, the actual future is quite here. One of the solutions is already available on the market, and we've been using it for a number of years. Okay, so our InSleek technology is a biocide-free, high solids system that's been used on over 8,000 applications for over 30 years. It's a proven technology in terms of it has 0 biocides, so we can apply the product anywhere in the world. But also, it has a slightly different view on decarbonisation. It has the lowest carbon footprint for any fouling control product on the market, which is a different concept I'll come to a little bit later. And it's the only technology to have generated voluntary carbon credits for the shipping industry. That is proven and validated emission and fuel saving capabilities from a fouling control coating. I would say we've been selling this product for over 30 years. I actually joined the company in 1993, and we started selling this commercially in 1994. So we have a number of firsts, and I could probably fill a whole slide deck with lots of pictures of different things that we've done first with this technology. Just to say, really, it's used on virtually all vessel types. But what's important is having the right vessel type. It's not applicable for absolutely everything. We were just talking, Nikos and I, for vessels where you're doing lots of short sea voyages, lots of damage potential, it's not suitable. But for deep sea, ocean-going vessels, it's absolutely eminently suitable. And we've also have independent validation in terms of fuel-saving capabilities of these products. So Professor James Corbett presented this at the IMO in 2001 to actually show what 2011, what the fuel-saving potential for these sort of products were. As I mentioned, carbon credits from the voluntary sector, so not to be confused with the EU ETS in that respect. Over 178,000 credits were issued in our first claim. So 178,000 carbon credits is 178,000 tonnes of CO2, validated and verified as being saved from the 16 vessels of this claim. I'll let you do the maths with the fuel saving. As I mentioned, we have now over 8,000 applications of this product, and it continues to grow. The speed and pace where we are selling this product now is increasing. We're seeing a lot more interest in this product because it's seen as capable of improving and maintaining the efficiency of the vessels. So a quick brief one of how it works. There's no biocides, so there's nothing there to kill any organisms, deter any organisms. So the InSleek systems work on a pure mechanical, physical way. And we do this by having I apologise here, I'm a chemist, but we do this by having an amphiphilic surface, which is both a surface that is water-hating and water-liking. Our scientists back home like to describe this as confusing the barnacles. They don't know where to settle. But the key thing is, why is that important? Now, traditional silicone systems are generally described as hydrophobic. And these are actually great for things like barnacles and mussels because they find it very difficult to attach to the surface. They find it difficult to have a very tight adhesion. Whereas slime, on the other hand, a different sort of fouling community, finds it very difficult to finds it very easy to stay on the hydrophobic surface. The converse is true for a hydrophilic surface, so animals like to stick to a hydrophilic surface, whereas slime doesn't like it. So we need to get that balance in there, and that's where the amphiphilic surface for the InSleek systems come from. Getting the right chemical balance without actually emitting any chemicals. So, I've said we've been selling this for over 30 years. And so we have many vessels with track records on the same vessel for over 20 years. So this is one example of a LNG carrier that we coated at new build in Korea in 2008. You can see the picture there on delivery. She has since had 3 maintenance and repair dockings. And when you actually look at the numbers of what really that means, so that's 20 years without use of biocides. So that's more than 43 tons of biocides not being emitted into the environment. because we haven't used an SPC biocidal antifouling. So all of these numbers are in comparison to an SPC antifouling. So you can see big numbers, 770 tons of carbon footprint avoided, 770 tons of carbon equivalent, 19,000 litres of paint saved. As a paint company, that's a wrong thing to say, but we're actually saving paint being consumed by this product because it lasts so much longer. VOC eliminated, reduced, and if you use conservative numbers of 5% fuel saving, you can see quite big numbers for this vessel. Similarly, smaller vessel, feeder container in this example, but you see very similar numbers. It's a proven technology of time and time again, application after application. This is a 15-year docking cycle. This vessel was docked last year for its previous cycle, so it's going for another 5 years after this. Now, I mentioned carbon footprint and product carbon footprint. We have decarbonisation targets as a shipping industry, but we also have decarbonisation targets as individual companies. So my company, AkzoNobel, we are proud to be a sustainability leader. It's a leadership position that's recognised by external validation bodies like EcoVadis and Sustainalytics, but also our customers also recognise that we are the leader in this area. We are the top leading paints and coatings company in any sustainability analytics. As part of that, we have very clear key performance indicators as a company. And I want to focus really on that top middle one, which is where we have a 50% reduction in carbon footprint across the whole value chain. So that basically means carbon footprint from cradle to grave. So it's not just our own operations, it's actually the whole carbon footprint in that respect. So let's look at carbon footprint in a little bit more detail. So those of you in the know will know greenhouse gas emissions are split into these scopes 1, 2, and 3. Scope 1 are your emissions direct that you create yourselves. So for shipping industry, that's your fuel burn. The fuel, scope 1 for the shipping industry is the big one that we've been talking about in terms of decarbonisation. Scope 2 is where you buy electricity for maybe your office uses. And scope 3 is split into upstream and downstream. Upstream is your suppliers, downstream is your emissions from your customers as a direct consequence of your activities. Where we can help in terms of our technologies is that the Intersleek technology can help directly with the scope 1 emissions in terms of minimising and maintaining the efficiency of the vessel and therefore minimising and maintaining the emissions from the vessel. So it's this one step towards that decarbonisation target. The other side of it, with our own targets to reduce our carbon footprint by 50%, means that the same product that you buy off us today will have a much lower carbon footprint in 5 years' time. So if you bought...
Trevor, 1 minute, please.
Brilliant. If you bought a product from us 5 years ago, compared to one in 5 years' time, it'll be a 50% reduction. So we immediately, through our own ambitions, our own activities, help you in your scope 3 emissions. So that's that whole concept. So my last slide, perfect timing, hopefully. So we've been delivering services and technologies that can actually help minimise the emissions from the shipping industry and with the Intersleek for the last 30 years. So we first launched this in 1994, as I mentioned, Intersleek 425 for something called fast craft. So these are the fast aluminium type ferries. We expanded that to Intersleek 700 for the more scheduled ships, the LNGs, containers in 1999 in response to the IMO AFS convention that was coming through. In 2007, we introduced Intersleek 900 for the slower, less active ships, so the tankers and the bulkers. And ultimately, in 2013, the Intersleek 1100 SR for more slime control, for more wider use of these technologies. So the question mark is, where does it go? I won't give away the secrets, but look at Posidonia this year. We'll be delivering, hopefully, something very positive. But the key thing is we constantly innovate to look at more sustainable solutions in collaboration with our customers. Thank you very much.
Thank you very much, Trevor. Our next speaker will be Dr. Nikolaos Liapis, managing partner of Acta Non Verba and president of HIMT. He's going to talk about marine fuel hygiene as a sustainable enabler, the fuel right holistic approach. 15 minutes, Dr. Liapis. Thank you.
Thank you very much. Thank you very much, Mr. Chairman. Good afternoon, ladies and gentlemen. Thank you very much. I will, for the invitation, I will talk for another disruptive technology here concerning chemistry and about fuel right and its innovative solution for shipping. So, is it possible to see it here in the monitor as well, the presentation, please? It's here. Thank you. So, Fuelrite is a US company, more than 30 years in business, producing fuel additives, starting from land uses, but now proceeding to maritime uses as well. We would say that it is a disruptive technology and a holistic technology as well. So it treats all the fuel system and supply system. It treats in a very good manner fuel filtering and delivery, and also it enhances engine performance. So working as a 3-to-1, we could say, as a catalyst, as a lubricity additive, and as a biocide. It's not a biocide, though, even if it can dilute microbial sludge and fight this big problem. So the main idea behind this technology, this exceptional chemistry, is that it produces clean fuels, dissolving agglomerate, dissolving any big particles that we will find in the fuel, and also making a very thin film in every metal surface that it will find, increasing in this way protection against corrosive substances that we find in fuels and water, etc., and also enhancing lubricity this way. So there is a big range of products for shipping and heavy fuel oil. It's recommended the more concentrated, the 30K additive, which has a treat rate of 1 to 30,000 to 30 tons, let's say, in 1 liter for 30 tons. So there is already a big experience in all kind of marine engines, in all kind of vessels, from service vessels, tugboats, but even the big merchant vessels as well. So starting from what Fuelrite does, it starts from cleaning the fuel tanks. You can see here it got tanks from diesel, of course, from gas oil, but it started with no sludge, no sediments, nothing inside, cleaned by the additive itself. And with this triple way to act, this triple action, especially with putting this very thin, even molecular layer, that this surface will, as we said, will protect any metal surface. The first thing to do is to extend the injector life, because it is very well protected from any cavitation and any microparticles that will create problems to that. And this means, as you all know, very good combustion and very good engine efficiency. Then we should have, and we have very clean purifiers, strainers, filters, all the fuel system that we see in there. It means that we can notice very high extension in service intervals. We can notice even 30 or 40% more time to clean filters, etc. So we have also a very big reduction in deposits that are built on strainers, and of course, reduced wear on purifiers and components. You can see here some pictures from strainers without and with the use of Fuelrite as an additive in fuel. We have, for another example here, for a testimonial from the chief engineer of one of MSC vessels. He said that really so that the cleaning of filters and the purifiers, it was not very dirty, not as it used to be, and with longer time intervals for cleanliness. And they are proceeding after this test with another use of the fuel additive. So this is a Greek vessel, Hellene Poseidon, running on 80,000 hours. It was a Daihatsu engine, 4-stroke, after 8,000 hours of operation, it was IFO 108 as a matter of fact, no hard deposits, no carbon deposits, no scoring or minimal scoring would say. It was like operating just now, no hard carbon deposits as well, as you can see. So we can see a lot of reduced carbon deposits in the exhaust posts, in the valves, in the cylinder, which means that the whole engine is protected in a way, and also there are no particles. So it acts like a detergent and as a protector and lubricity additive as well. And we can see that furthermore, there is a very well-known, especially in the automotive industry, that's called ISO 4406. It has to do with the cleanliness of fuels, and especially the reduction of particles, of the size of particles and the number of particles of this size. And in this, we have made a lot of tests, and we have seen exceptional performance from Fluoride additive. So we have especially in the automotive industry, but it can be extended to all engines, of course, that we have strict direction and guidelines from the car manufacturers about the limit in particles and size of particles, a number of particles of this size, a specific size in fuels. And we can see that the use of Fluoride reduced in a very high degree all these particles, especially the bigger particles that can really cause problems with injectors and in this way to extend the engine life. There is a test that Fluoride has developed itself about seeing what is the protection against corrosion, as a matter of fact, and we have tested for a long time now our products in comparison with competitors, and you can see that with Fluoride there was no corrosion because, as I said, this surfactant amines, which is the main technology behind these specific additives, this family of additives, they protect all metal surfaces that are in the fuel even for a long time. There is no corrosion or sludge formation. And another very good property that we could measure in fuels to see exactly what is the tendency for filter blocking, and this means what is the problem with fuels in general. This will show also the stability of the fuels, especially in heavy fuel oil, is the determination of filterability with the filter blocking tendency, which is one of the very good indicators to see about that. And you can see that we have reports here from Bureau Veritas analysis that a fuel that was above the limit with the use of Fluoride, it went to the limit. It means that it was a very good fuel after the treatment. We have seen also, because of this complicated and cumulative, let's say, actions of the family of additives, that we could have reduced emissions, and this means that it acts like a combustion improver. In general, we can see that we have more than 60% reduction in hydrocarbons in the exhaust gases, and also a very big reduction in smoke, nearly 40% reduction in particulate matter, which is mainly the smoke. And this means, of course, a better combustion overall. We have seen also fuel economy in field tests in various companies that are using it. For example, Ditas in Turkey, minus 4%, Lean Shipping here in Greece, minus 12%. This was a huge number. It has some other factors as well, but it was big as well. China Energy, we'll see later on, minus 6%, and the tax from the company in Canada, independent tax, minus 10% nearly. So we have a very good example of a big shipping company in China. It's called China Energy Shenhua. It has almost more than 40 ships operating in HFO in 380. All the fleet is using Fluoride now for a long period. They've seen a very good reduction in their fuel consumption. As we said, something like minus 6%, which this means for the 40 vessels fleet of the company, it would mean an annual saving of nearly $5 million, which is really something significant. We say in Fluoride that for each dollar that you invest, you can take back $4 to $5. So also emissions were reduced a lot. Okay, we don't know what will happen with IMO and we'll go for next year, but reduced emissions always means also reduced cost for fuel, and this is what we must keep at the end. Of course, in order to, it's not so easy to measure fuel economy in a field, in the field test, and while traveling, it's not a bench test, but we have developed a protocol for that. It's a little bit complicated. We must really measure specific things and also have a big number of data to be recorded in order to make all the corrections and have the accurate, let's say, measurements for the fuel efficiency of the vessel. Even weather conditions and wind and waves in order to make all the correction actions. But this will lead to a good field test. Of course, we need also 3 to 6 months in order to be sure that the results are accurate and reliable. And this is about, thank you very much for your attention.
Thank you very much, Dr. Liapis. Quite efficient. If we continue like that, we'll save the 3 minutes that we need to hear Stavros' joke. Okay, our next speaker will be Mr. Jasper van de Kant. He's the sailing director of Marflex, and he's going to talk to us about efficient cargo operation in tankers.
Yeah, thank you.
Jasper, 15 minutes. Thank you.
I cannot make any promises that we continue like just before because it was really great. But Yassas, everybody, my name is Jasper. I'm from Marflex. You know, I think we live in very changing times, and change is often nice. It creates, of course, new things, and it starts with trying new things. So one of the changes I noticed is that, for example, in the US, we see, presidents and captains of industry doing a small dance when they are, let's say, in events like this, or important events. So my marketing team thought also, Jasper, try the same because it's a new thing. But then I showed a little bit how I dance, and they said, "Oh, skip it. Better to focus on the content." So we have something exciting to discuss today. The focus will be a little bit on tanker operations, or actually it will be on tanker operations, cargo handling to be precise, and it captures all the things which were discussed before. I think in general, nobody really knows what is the next best fuel, But we all know that if you capture efficiency on board, or if you select equipment, or help the crew to be more efficient, that's in any case always a good thing. And this is what I'm going to present right now. I think Marflex, we stand for to help the crew on board make tanker operations more safe, efficient, and profitable. And luckily, we have a lot of technology doing that. Let's first start to have a look at what does it actually mean, cargo pumping, tanker operations. The challenge with cargo pumping is that everything is happening below deck, and we have large vessels. There are so many variables influencing cargo pumping, like different tank level measurement of tank levels, behavior of the crew, behavior of the terminal. So it's a very complex but critical system. It needs to be done correct, perfectly safe, and as efficient as possible. What you see here is electric motors, and that's the main topic of today, actually. I'm here to explain about possibilities of changing from a mechanical drive to an electric drive. It's been mentioned before. It makes sense. You always need a fuel to generate some kind of power. But the less transitions you make, the better it is. So, for example, shore power, it's electricity. Why don't you just connect it directly to electric consumers, like electric motors? And that's actually the case for cargo pumping. The same, You know, use electricity, don't transform it to hydraulic power or any kind of other power, just use electricity directly. What you see here is a typical pump curve, typical behavior. We have measured with many ship owners, many different discharges, and every discharge is different. What you see here is around 8 million data points where we have logged the operations of crews on board of tankers. And this operational excellence area is actually where you would like your crew to discharge. That's best efficiency. But you see, unfortunately, the majority is outside of this best efficiency range. So I will return a little bit later with a question for all of you. I hope you're still awake at the time. So anyhow, cargo pumping, it is very complex. There are so many variables, and I dare to say, you know, it is impossible for the crew to do it right, no matter how good you train them. And let's be honest, you know, it's already a challenge getting good crew, maintain them, keep them in your company, and make sure they always do the right thing. A discharge takes 24 hours, you know, so. So then, last night I came up with this, I think, pretty okay formula. I don't know if it's technically correct, but we can discuss it later. I dare to say safety is your equipment, your processes, plus your crew. And if you do that all correctly, it is efficiency. Because one little screw up in that process, excuse me for the language, is really hurting your business, and potentially much more. So, this is actually a depot pump. It will be installed in the tank. For those of you who operate on tankers or are familiar with tankers, it looks a lot the same like a hydraulic variant, and in fact it is also in terms of operation really the same. The main difference is the electric drive. So the blue is the motor, just below that is what's on deck, and the rest is below deck. And in the bottom of the pump there is an impeller turning, and this actually moves the cargo, the liquid, up. This is cargo discharging. And the advantage of one pump is to have one pump per tank, so you can, you know, discharge multiple grades, multiple cargoes. This is called stripping. It means emptying the remains which in the pipe stack. Sometimes it's 80 meters long, so that's quite a lot of liquid. And this is super stripping, and super stripping, as you can see right here, it completely drains the well, which means less tank cleaning, less waste, so that's a good thing. This is nothing new, but it's an important thing to realize. Oh, can I go back? Okay, we had this. So, avoid losses. So, for example, a hydraulic-driven system requires some kind of electricity to generate a hydraulic power. You need high-pressure hydraulic lines on deck, and that's a waste, actually. Better to just directly consume the electricity there where it belongs. And again, making the transition from a hydraulic-driven system to an electric-driven system, it is not a big change. Your crew will know what to do, and I dare also to say, you know, young crew, new seafarers, they are more familiar with iPads and digital processing rather than mechanical. So, how to maximize efficiency? Select equipment that consumes less energy. Help the crew to avoid damage and inefficiencies, avoid inefficiencies, and increase operational efficiency. And I think the electrification is the main red thread through all the discussions that we're having today. Let's electrify. Talking about electrification, you need a drive system. It's been mentioned before, Tsakos also referred to it, variable speed drives. It's the way how an electric motor is driven. And you can imagine if you have multiple cargoes, they all have different dimensions, different specifications. Some cargoes are lighter, some cargoes are heavier, so you need to have a variable speed to operate, you know, to select the best efficiency. If you go to electric, you have a much smaller footprint, you have more room for cargo. It's easier to install for the shipyard. So there's a lot of benefits to it. This is maybe a little bit too much detail, but this is a drive system, how it usually is configured on board of a ship. If you have 12 tanks, the old standard is, it's a matrix standard, you use six drives to drive 6 pumps at the same time. And we have introduced a new system which is called full drive. Full drive, which means that you can run any pump basically at any time, meaning complete operational flexibility. And this is what it looks like. On the left, you see a traditional system. It's very, the blue things that you see, the 3 on the left, those are the things which actually do the work. And the rest is just there to make the matrix. So they don't add value, it just consumes power. So we stepped away from that concept and moved to a more simple and more easy and more flexible to operate system, which you can see on the right. It saves a lot of space, and the crew will know, the crew can easily replace a drive if something is failing. So in summary, switching to electric, you have a lower capex, you certainly have a lower opex, and you're much more efficient. And I think also if you have efficient tonnage, your trade chances will be better, and you will make more profit. So again, this is a typical pump curve, and the yellow and the green is where the crews have been operating. You want them to operate in this efficient operation area. These are, I think, around 4 million. This is an actual discharge. It's around 4 million data points. So let's take a guess. Can anybody who thinks how efficient is an average discharge? Are we going for 40%, 80%? Can I see some hands for 20%? Yes, we have. Thank you, sir, for joining. But actually, you're right. So So okay, yes, this is a typical cloud. If we help the crew, and again, we have technology for that now, to do the right thing on board, there is significant time and energy saving. Because this is actually true. This is what we have measured over the past 5 years on board of vessels, multiple vessels. On average, 22% of a tanker discharge is efficient. There's a lot of room for improvement. And then cavitation. Inefficient, you have, maybe let me go back a little bit. You see here on the right side, after the red line, that's actually cavitation. And cavitation looks like this. This is the bottom of the tank, and you see holes in the tank top, up to, let's say, almost a centimeter. This is a significant hazard. You will notice it much too late, so it needs to be prevented. And also there, luckily, we have technology now to do that. Cavitation, in simple terms, means that you're running your pump faster than that the liquid can enter into the pump. And that's when cavitation starts. When your tank is very full, it's okay because the cargo pushes it down. But when the tank is almost empty, which you can see right here, then there's a high chance you're running your pumps faster than that the liquid can go in it, and you will have cavitation. By automatically adjusting speed and the valve position, we can save a lot of time and avoid cavitation. And yes, I really think it's impossible for the crew to do it right unless we help them. And this is what it looks like when we help them. Again, on the left side, you see the normal discharge. And on the right side, you see a discharge which has been done with smart pump technology, automatically balancing the speed and the valve position of each pump to meet the terminal requirements. It's a significant time and energy saving. Also, I think, again, the electrification is the trend which is going on right now. This is a copy of the DNV report, also highlighting, use variable speed drives, consider electrification. It's really a quick win. I think actually I did it in time. So let's have a talk, because change and improvement starts with a dialogue, an open mind. This is not new technology. I mean, the electric-driven depot cargo pumps are here already 50 years. Yeah, I'm proud, yes, Marflex was one of the inventors of it, but there's still together, you know, a lot more room for improvement. So let's have a talk, and thank you very much for all of your time.
Thank you very much, Jasper. Our next speaker will be Mr. Denis Kainer. He's Global Product Manager, Shipside Shore Connection for ABB Marine and Ports. And he's going to talk about an innovative midship shore connection solution for tankers. 15 minutes, Denis. Thank you.
Thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. My name is Denis Kainer. I'm Global Product Manager for Shore Power for ABB Marine and Ports. Background, I'm electrical engineer by background, 18 years in marine, a decade in class society in Norway, Korea, Turkey, followed by involvement in various positions in electrical system integration, integrator companies. Lately, I've been involved in shore power for several years now. We have heard very insightful discussions and information about the Net Zero Framework, MEPC meeting outcome of IMO from last month in the previous presentations. I believe this slide, this caricature captures the summary of it in a nutshell. What happened last month? Nothing happened. The IMO pushed decision-making for another year. That said, the timeline of IMO is there with a target of 40% greenhouse gas emission reductions, striving for 30% by 2030 and net zero by 2050. Although the momentum has slowed down, the new regulations will come also for tanker vessels. The complexity will increase. While there is slight delays on the adoption of global regulations, the regional regulations are expected to lead the developments in this area. And for instance, in California, the CARB regulations are already applicable from the beginning of this year in Port of Los Angeles and Port of Long Beach. And by 1st of January 2027, they will be applicable for all tanker vessels visiting all regulated Californian ports. That will be, however, various emission reduction methodologies, shore power being one of them. You also have regulations, and port authorities and charters incentivize compliance and readiness. Therefore, it is best to act as soon as possible before it's too late to avoid penalties and have market access. That being said, although the shore power has been a proven technology in various ship segments like container vessels, cruise liners, RoPax, RoRo, ferries, it is rather more complex and challenging for tanker vessels. As you know, majority of the tanker jetty terminals, T-jetties, finger jetties, have the infrastructure to allow only having the interface to the vessel on the midship, whereas the aft of the vessel, as the terminals serve various sizes of tankers from small product carriers to Aframax, Suezmax, VLCCs, it is rather complex for the terminal to have a moving infrastructure to connect on the aft. While aft connection is rather easier, it stays out of the access area, interface area for the terminal. On the other hand, midship is hazardous area during the cargo operations, which brings extra complexity that requires explosion-proof solutions to ensure safety. Having also, the terminal side is also hazardous, and finding a proper cable management system is also rather challenging. On the midship cargo deck, tankers are full of cargo piping and cargo hoses, so dimension constraints are also adding on top of it. Picture on the left gives the side view and top view of a vessel with hazardous areas. As you know, majority of the areas are full of, all the colored areas are zone 1 or zone 2 areas. And there's bits and pieces of safe zones here and there, but that's really not easy to have an installation in the midship. Aft, on the other hand, is safe zone. So we do have solutions for both. We have representation in IEC Global Standardization Committee developing the tanker-specific regulations, as well as on the OCIMF committee. OCIMF released their revised guidelines on shore power back in June this year. We are adopting all the requirements to our solutions. Our aft solution is already operational on ships visiting Port of Long Beach. And the midship solution requires rather more safety focus. So from the beginning, we have worked with ABS. We ran a hazard workshop back in spring this year with ABS and adopted their recommendations into our design, and it's currently undergoing approval in principle with them in ABS in Houston. We also filed utility model application for some IP protection. So what we have for midship is a self-enclosed deck house that is overpressurized using ship's compressed air, and that is the sole air source into the room. This is normally you would, on a conventional design, you would have artificial ventilation, but having ducting, ventilation ducting, 20 meters from the deck house in midship to a safe zone, 20, 30 meters, is not really easing the installation. So we do have advanced filtration techniques to ensure that the compressed air is made into a OSHE compliant breathing air, because you need to enter into the room to couple the cables and also during the for maintenance occasionally. And additionally, we have filtration for oil vapors, because we are using compressed air. You cannot really tolerate that. So there is zero oil vapors entering into the space. This way, we are preventing the ventilation ducting, but additionally, internal arc is a critical safety aspect that must be very carefully mitigated, otherwise you would have an explosion. For that purpose, we have adopted ABB's state-of-the-art arc quenching technology that is called ultra-fast earthing switch. What it does is it detects the arc flash inside the shore connection cabinet in the deck house in less than 4 milliseconds and extinguishes it almost immediately. So within 4 milliseconds, the arc is eliminated by creating a short circuit path to the ground. With that, normally you would, with conventional methods, would take around 80 to 100 milliseconds. That is not sufficient to have a low pressure. The arc pressure and the thermal energy is so dramatic that it is very critical for that environment. With UFAS, we are reducing the pressure peak to so low values that it is not only tolerable by the environment, it's also eliminating the need of having an external arc ducting to a safe zone. Therefore, you can then safely vent it out to the environment. UFAS also provides the benefit of protecting your shore connection cabinet and equipment, and within one day you can just go back to the using shore power once you replace a simple component in it. That said, even without the UFAS, the structural resilience, the structural integrity of the deckhouse is calculated through FEA analysis to ensure that it can withstand all green water effects during transit, but also internal arc failures and pressure peaks on those occasions. The solutions for aft and midship have commonalities. So what you would typically have is that this is where the industry, tanker standardization industry is leaning towards, is even though majority of the vessels are low voltage, 6.6 kV shore connection is being adopted. This is likely to be reflecting to the upcoming normative tanker-specific annexes. So you have a 6.6 kV high voltage shore connection switchboard on the aft in the safe zone, a shore connection cabinet either on the aft or on midship, and in case of midship, it's in a pressurized and purged deckhouse. Then you have to step down the voltage using transformers. Our solution, therefore, has the shore connection switchboard that allows connection on aft, for midship, or both. The other ship interfaces are the deckhouse is installed on the deck, some basic welding. It has various safety equipment, including emergency light and fire detection, which are extension of the ship's systems. The switchboard and the shore deckhouse is integrated to the ship automation, branching off minor modification of the compressed air system, and to ensure seamless load transfer from ship to shore and shore to ship. Power management and gensets have to be properly regulated, and minor upgrade there. In summary, what we are offering is a smooth path to regulatory compliance. Our solutions are designed with class involvement, with high focus on safety from the beginning. Easy to integrate, the way the solution is designed, especially for midship, it is made into a compact deckhouse with minimized, no need of ducting, which allows ease of lower installation cost and ease the installation. And of course, as ABB, with our global service network, we are providing life cycle support to the lifetime of the vessel. Thank you very much. If you would like to discuss further, please scan the QR code and we'll reach out to you.
Thank you very much, Denise. Our last speaker will be Albert Vandel. He's the Business Development Manager for Leva GmbH, and he's going to talk about pumps for alternative marine fuel. 15 minutes, Albert.
Yes. Hello, ladies and gentlemen. Very warm welcome also from my side. Thank you for the invitation. I want to talk today about pumps for alternative marine fuels. And I want to start with that slide here. We think one of the key fuel will be ammonia for the future, because ammonia is really reducing carbon emissions by up to 90%. So there is no more C in the formula, it's just NH3, so there will be no more C left. The energy density, of course, is not higher than on HFO, but it is higher than for hydrogen on a volumetric basis. And there is existing infrastructure already. Since decades, You are transporting ammonia over the oceans. It's one of the basic chemicals. So there is infrastructure there, but now it's on to adapt it to the supply chain as a marine fuel. Here, that's a slide from Everlands, and it shows the fuel mix in the future, and also you see here that ammonia will be a significant role. Also, we heard this in the morning from Everlands. We, from LEWA, we are focusing on LPG and ammonia. A few words on this later. The question may be now, why LEWA? You see here, it's ammonia. It's dangerous, it's harmful, it's poisonous, toxic, and LEWA is handling those fluids all in the chemical plants worldwide since decades. We really grew up with those guys from the chemical industry. We have pumps worldwide for ammonia everywhere on the globe, and critical fluids and processes is really our, let's say, daily business. Yeah, a few things to the history. We are a German company located in Stuttgart in the southwest of Germany, founded in 1952, and our step in to the marine business was in 2012 when we supplied drive units for Cryostar for their pumps, and really we got into 2017. We received a request from, at that time, MAN for the testbed in Copenhagen, where we supplied the pump for the testbed there for LPG. Then I would say during COVID it starts really that we are receiving purchase orders for LPG high pressure pumps. And the last 2 years, yes, we received, as we know, all the orders for the ammonia projects. The general design of a process diaphragm pump, we have 3 parts. One is the electrical motor. We have the pump head. You see it here in the picture in the stainless steel on the front end. Three pump heads here on a triplex pump, and the drive unit in a compact monoblock design. It works, yes. You see here the blue end, which is the liquid end for LPG or ammonia, and you see the orange side, which is the hydraulic oil side, and you see the drive end here on the back. Well, the key here component is the sandwich diaphragm, PTFE diaphragm, which separates the liquid end from the hydraulic end. And this has to be 100% safe. So we have hermetically tight pumps. There is no dynamic sealing anymore. It's just a static sealing. So we have really zero leakage here. You see on the discharge line, there's a small pulsation dampener. It's to really have no more pulsations left. We have a reciprocating pump here, so we have to eliminate everything via this pulsation dampener. Yeah, if you look on this slide, if you flip the LEWA pump for 90 degrees, it looks very, very similar to the main engine. There is an eccentric shaft, there is a connecting rod, plungers, injection valves, so it's really similar to the main engine. Sometimes we hear, oh, your pump is a kind of complicated and there are so many moving parts and things like this. Yes, but it is really reliable, it's really heavy duty, and you can run for decades with that kind of pump. Here is a typical P&ID to give you an overview where our pump is located here. We have the FGSS module with the LEWA triplex pump, the fuel valve train, and the main engine on the bottom right side. Yeah, here is the FGSS sweet spots for us. We are really focusing on two-stroke engines, medium, large, and very large carriers. We are focusing, as mentioned, on ammonia and LPG. We can also do methanol, yes, but there the supply or injection pressure is at 16 bar. There are also other solutions who can handle those kind of, I would say, low pressure. Yeah, why the lever pump? We can handle both with our design, LPG or ammonia, it doesn't really matter to the material here. We have more than 700 diaphragm pumps delivered already to the chemical industry for ammonia, so it's a huge reference list here. And those pumps are usually working on higher pressures, like here 300 bar and more, up to 22 cubics an hour. Yes, we have here the selection criteria. If it comes to a lever pump, of course, the selection criteria is the injection pressure. The higher, the better efficient for you to use a lever pump. 100% dry safe, really zero leakage, as mentioned before, and also very high efficiency. This is a graphic from a university here, and you see on the top left side, you see the reciprocating pumps, and they are above 90% of efficiency. If you compare to other suppliers for that pump, they are at about 30, maximum 35% of efficiency, which is a big difference, and it will save you later on a lot of also money in terms of energy consumption. Easy maintenance, it's possible to do a diaphragm change on board. Very high operational safety, high availability, and yes, very robust design, so really ideal for seagoing vessels. Of course, we have all the certifications we can handle as well. Here, that is what I mentioned just now. If you're looking for a lever pump, yes, the initial invest will be higher than with a centrifugal pump, but it pays back really fast. You can save for LPG about 20,000, for ammonia about 30,000 euros a year, just because of the energy consumption. So the operation costs are much lower than if you run with a very not that efficient pump. Here, an overview where we are located. I told you already the main factory for the pumps is in Stuttgart, but we are really, we have subsidiaries all around the globe. Also with a number of service engineers, you see in the circles always, they are really coming to us, to Germany, to get training on the pump certification so they can handle it. And yes, we are also in the oil and gas business, so we have also this offshore certifications to go on board vessels directly, and if there is something, issues coming up or whatever, we are close to you. Yes, I would say thank you very much for inviting me here. And also thank you very much for our partner here in Greece, which is Ocean King, and thank you.
Thank you very much, Albrecht. We have about 20 minutes, so that means we'll have 20 minutes. That we'll have some questions. I would like to ask Simon, Jasper, and Albrecht. It seems that the majority of the makers, now they want the owners, the operators, they want them to sign a maintenance contract. They want to supply the spare parts, and also they want to provide the service engineers. Do you think that this creates a monopoly, meaning that maintenance might not be competitive, and also that you're removing competency from the officers on board. Who wants to start?
Well, what we see is, yes, with the spare parts, there is some thinkings going around really to handle this by the fuel gas supply systems integrator, or to leave it on the owner side. I would not say it's a fight. It's more actually, a kind of negotiation and how to get the best beneficence out of it in terms of also on the cost side, of course, for the spare parts. Yeah, sure.
Thanks. Thanks for the question, indeed. Marflex follows a little bit different policy, you know. We started 20 years ago with making reports, and then we went to ship owners and we told them, look, this trip 3 months ago, if your crew would have done it differently, you would have not had these issues. And it's nice, but it's old news. And so we changed the way of thinking, and we started focusing on, as I just mentioned, to help the crew avoid create damage or breakdown, and things can always break. Even Marflex pumps, I'm sorry to say, sometimes they do break. But by adding this clever technology on board, like the smart pump technology, we avoid cavitation. We know that the pumps are used in the right way. It allows us also as a maker to give a 7-year warranty to our ship owners to together prevent service calls, service issues. So we don't have service contracts, we don't have agreements, we just, we believe in working together. And of course, all of us, we have to make money, but we need to do it respectfully to each other.
Simon, you want to add something?
Sure. Maybe I make some comments towards the monopoly aspect. I think for us, we are not limiting our competitors to also follow in the same way, signing maintenance agreements. I think, at least from my perspective, we are leveraging our capabilities. We have a global service network, and it makes sense for me that we would enter a maintenance agreement because, if we look at, for example, cost, we will not be, let's say, on the same level as some of our competitors. So we try to bring forth our values in a different way. And I think one of those things is signing a maintenance agreement where, let's say, in a way it implies we take on some risk in exchange for a commitment in the long term. Thank you.
Thank you. One question for Dr. Liapis. Why do you think that shipping companies have not embraced the use of fuel additives?
Well, historically, there is a number of reasons, as a matter of fact. And being with the same fuel for a very long time, it offers a security, let's say, safety about that. In the beginning with additives, there were not many additives claiming fuel economy. So there was only some asphalted dispersants, which most of the companies used when they had a problem with heavy fuel oil, with non-stable, let's say, heavy fuel oil. But now that we have all this discussion about fuel savings and greenhouse gas savings, etc., so there is the technology, and there are more than one company. It's not only fuel, right? There are other companies claiming fuel economy and fuel efficiency. So it's a matter of technology in general. Technology matures by time. This is a technology coming from the automotive industry that moved to shipping industry as well. And maybe there is another reason that most of the companies, they don't pay for the fuels because the charterers pay for that, so they don't give very much attendance to that. The attendance came now that they care about the greenhouse gases and the CII, etc. So this is why, for example, in SEM, you can put your additives in your plan for the measures that you'll take for reducing your or enhancing CII performance. So I think there was even the engine manufacturers, they were not very fond of additives. Some 1 or 2 decades ago, but now I don't think there is a problem on that. So, from historical reasons, there was a number of reasons that shipping companies, they were not trusted, let's say, additives, but I think more and more companies go into that now, and I see that they use fuel additives and they can see the results. But also there are some additive companies that they have very, very specialized for only one action, let's say, which is not needed at all, as asphalt is dispersed. You need it only when you have a problem. But multi-action additives like fluoride can be used all the time and for a number of benefits, let's say, that will bring your money back.
Thank you.
I have a question for Charis. When you buy a new car, 30,000 euros, 40,000 euros, what kind of warranty do you get from where you bought the car? And do you take the car, do you do the repairs yourself? Do you take it to a nearby workshop, or you take it back to the dealer?
It really depends. If it is an expensive car, I will take it to the dealer.
Okay. So a turbocharger costs $400,000. A main engine costs 6, 7, 8 million, depending on the size of the engine. And we still have the 1-year warranty, and we're still arguing who is going to provide the spare parts and who is going to do the service. And we talk about new technology. It's a personal question, Harry.
I agree with you, Stavros. I remember we had a case with one of our new buildings for the auxiliary engine turbocharger. We were discussing with the shipyard who is going to provide the tools for overhauling. So I was in the middle. It was the shipyard on one side and the maker on the other, and we were discussing who is going to provide the tools for overhauling by the crew. And they said, we are not going to do it. Either party, they did not want to provide the tools. Anyway, that's irrelevant. But obviously, turbocharger, main engine turbocharger is a very, very expensive piece of equipment, and it's also critical. If you have a damage on your main engine turbocharger, then the tugboats will come most of the times. So we don't do, as a company policy, we don't do, let's say, overhauling of main engine turbochargers. We only do it with the makers, either the maker or the authorized workshop. But it is important to clarify that if there is an emergency, the crew at least can do a few things to make sure that there is no further damage, or to let's say, put the equipment back in operation.
So you have an expensive car or a cheap car?
I'll tell you after the break, and then you tell me the joke, Stavros. Yeah. Any questions from the floor, please? Yes.
Well, sorry. So it's an answer to your question, to the manufacturers, something else. In the shipping industry, we have agreed to accept the polluter pays and the pay-as-you-throw principles. Although in the European Union, they promote the circular economy and the extended producer's responsibility. That means, and you should answer like that. It's not marketing what you're doing. You are supposed to get back the producer, the manufacturer has to pay, has to reuse, arrange to reuse, to repair. That's circular economy. So you have to do it. And you said somewhere from cradle to grave. So I don't think that the ship owners know what are their rights. And the rights are to ask for longer warranties and have the spares, at the time that they buy the machine. So please tell me if you included your marketing principles, the circular economy.
It's yours.
Yeah, I don't know if you would like me to answer, but I think what you're stating is more in line also what we believe. It's not so much about rights, because it's about cooperation. And I think if you as a maker or any company provide a value which is actually adding value to your partner's business, that's a good thing. That's, I think, what we need to achieve. And you're also right, we try to move away from this traditional maker philosophy. And like I mentioned, we did agree to offer a 7-year warranty to the market, because what I just explained. And you're also right that internally even, and we're a relatively small privately owned company, so we are quite flexible in making decisions. Even internally, it was quite a discussion to change the mindset of our own organization to offer this 7-year warranty to the market. And I think a service call is also an opportunity to learn. Because if the service call happens too many times, it means something. And we need to fix those things. So I would advocate, let's step away from the discussion of what's the price of a spare part, but let's look at the bigger picture and work together to make a long-term sustainable business. Thank you.
I think the issue is what Stavros mentioned. We are getting 1-year warranty from the shipyard. And what we try to do behind closed doors, every company, is we try to get an extended guarantee from the makers. So unless we get a bigger warranty, let's say for a car that Stavros mentioned, we are getting 5 to 7 years warranty. For a ship that costs, for a car that costs 30,000 euros, for a ship that costs, let's say, 200 million euros, like an LNG carrier, we're not getting an extra. We're getting only 1-year guarantee by the shipyard. 2 years? 2 years, okay.
Yeah, but the regulation, the European regulation, wants to promote the legal framework on the extended producer's responsibility, because it's the manufacturer's responsibility to take back. It's not, okay, usually you scrap the whole vessel, the whole ship. But the thing is, if they build up platforms to give back a non-suitable engine and take back another one. So it's their responsibility to build the platform and start the exchanges. That's what I'm telling them. It's not that they do it, for their goodwill. They have to do it. It's extended producer's responsibility due to the circular economy principles. That's what I'm saying. So it's something that it's a legal issue. I know the claims managers never do it. I was doing European grants, Horizon grants, so that's how I know the legal framework.
Okay, thank you for sharing it with us. Yes, Dimitri.
Thanks, Harry. Dimitri Mounioudis from Intercargo. A practical question to Dennis. I know that you presented on tankers, because Harry is chairing the panel. I'd like to ask what's going on the bulk carrier side, which is an even bigger market. What is ABB doing? Thank you.
That's the volume of, that's definitely a big volume of vessels out there. The bulk carrier industry has not been able to have a consensus yet on where to have the cable management system on board and on shore. So this is slightly being delayed, but we already have solutions with cable management on board for container segment. And these are very much adaptable to bulk carrier segment when it's out there, but currently it's leaning also towards high voltage shore connection, 6.6 kV most likely. That's what the Intercargo recommended to the standardization committee. But there is still debate between the terminals and ship owners on what will happen.
Thank you. And all I wanted to make the point, and you're absolutely right. the dry cargo side is looking for standardization across the world rather than having individual countries coming up with their own standards, and the discussions are progressing, but not as fast as we'd like. Thank you.
Thank you. Any other question? Yes.
Hello. Thank you so much for all of your... can you hear me? Thank you. My name is Mary Kate Scully. I am an undergraduate student from NKUA's Department of Ports Management and Shipping. And my question is mainly directed to Mr. van den Kant. You mentioned that the pump systems are difficult to operate correctly even from skilled crew with training. However, technology, of course, helps. I would like to know who provides the training, how costly it is, and what is the implementation timeline for the ships and their routes. Thank you.
Thank you for the question. Yeah, training never stops, I think. So from our perspective, at least at the shipyard already, when we do the installation, we support the yard, but also the initial crew there to do a training. But I think also many ship owners have, let's say, frequent, officer seminars where the crew goes to a certain location and discuss safety and training issues as well. That's also where I think Makers and at least Marflex does participate. And of course, we have cooperation with training schools globally where we really have a typical cargo scenario where we can do discharging. Am I answering your question, or did I miss something?
Yes, for the most part. I just wanted to know if there's any specifics that you give for your own pumps, or is that a general training that is implemented for the crew?
Yeah. It's a little bit of both. Of course, it starts with the pumps, how to operate it. But as I already mentioned, there's, let's say, three main types of pumps, and they're generally, a pump is unfortunately not rocket science, so they look a lot alike. So, but yeah, the operation, that's also a strong focus on, using the technology fitting to the operation. Thank you.
Any other question? I have a final question from Mr. Wandel, and the question is, you mentioned that it is 100% safe to use your diaphragm pump. Well, 100% safe we have not seen in the marine industry, so I'm wondering, you probably need a lot of precautions to be able to operate this pump safely on board the ship, moving and...
Yes. Actually, we have, as I mentioned, we have this kind of sandwich diaphragm, so we have two layers. And this is monitored via pressure transmitter, so if one layer gets a rupture or damage, you will get an alarm, and of course then you have to prepare to do some a new diaphragm change. And also there is like a backup pump usually on board. You can also... Actually, we are facing this, yes, for ammonia they are going for 2 usually per vessel, yes. To be honest, we really seldom see any diaphragm issues and ruptures. If we would have this problem, our telephone will be ringing the whole day, I think, with so many pumps in the chemicals. That's just what I can say there. Yeah.
Thank you. Now is the time to make a break for lunch. The lunch is sponsored by Lloyd's Register, and we will be back at 3 o'clock for the third session of our conference. So please enjoy your lunch and be back promptly. Good afternoon, ladies and gentlemen. We are ready to start our third session. It's called Next Generation Integrated Ship Management Solutions. And I would like to introduce Mr. Gregoris Poudalakis, Managing Director of Columbia Ship Management, Greece, who will be the moderator for this session.
Good afternoon also from my side, and thanks to the organizer, and I would like also to welcome you. I'm really inspired every time from our Spiros Zolotas, whenever he is a moderator. So I asked his advice how to start a panel. He told me, Gregory, say something about AI and marathon, because I'm a marathon runner. So even there, we can see that it can be used. I have an uncle that used his age to ChatGPT, his weight, and it gave him a training plan for 6 months. So just to start in this way, and without further delay, to introduce to you Martin Scholes, our Commercial Director of VAF, who is going to discuss on the digital journey of operation ships propulsion performance improvements. Thank you.
Everybody can hear me? Thank you. Good afternoon, everybody. My name is Martin Scholes. I'm Commercial Director with VAF, represented here in Greece by CROSS Technical Services, in the persons of Alex and George over there. And I'm going to tell you something about the digital journey of operational ship propulsion performance improvements. And to start, we've seen more or less this slide before, moving to net zero in 2050. Okay, there has been some discussions about that, but let's skip that aside, because we've talked about it quite a lot already today. Key trends, 2050, net zero. The second one is increased GHG legislation, imposed also by IMO, EU MRV, EU ETS, Fuel EU. And then the third one is alternative fuels, also been discussed quite often today. LNG, biodiesel, ammonia, and also methanol. And then the fourth key trend is energy-saving devices, mainly wind-assisted propulsion systems. And then the fifth one is digitalization. That's one of our specialities. Digital sensors, data collection, vessels are getting connected, and high-frequent data is needed for that. Cybersecurity requirements such as E26, E27 is quite a hot topic nowadays as well. A bit about VAF, founded in 1938. It's a Dutch company, and we say that 70% of the world fleet is using at least one of our sensors. Majority viscosity sensors, I have to be honest, but we also have torque measurement, fuel sensors. But that's what we say, and that's what we aim for. Global service and agent network. You see the picture of the globe. Basically in every maritime hub, we have either a sales and or a service agent. And we are part of Aalberts Industries, which is a Dutch stock-listed company. 3.3 billion turnover. We're a relatively small part of that, but to give you some background information. The solution that we provide for our customers in the maritime domain: fuel efficiency, environmental compliance, advanced data management, and remote onboard diagnostics. So if customers have a challenge or a problem with that, we are able to serve them. We're a total solutions provider, which means we provide the sensors, which you see on the bottom side, torque and thrust measurement, torque measurement, fuel, both displacement fuel meters as well as Coriolis flow meters, and as mentioned before, viscosity sensors. We can also connect third-party sensors to our data collection system, which you see in the middle side.
And that's one of our strengths. We are able to make the sensors. We make them already for many years, but we're also able to interpret the data that comes out of these sensors and to enrich this data and make it visible in a dashboard. We can also connect to third-party providers. So in that way, we are very flexible and able to connect to all kinds of systems. This is something about our dashboarding system. High-frequent data in the cloud, data analysis about propulsion performance, but also fuel efficiency and GHG reporting. Connect through an API with a third party if needed, which makes it a very flexible solution. We can also provide remote diagnostics, a bit in line with the previous discussion about service interventions, with the, let's say, the modern capabilities. We are able to remotely do diagnostics on vessels, so we don't have to send over an engineer across the globe, but we're able to do that remotely. Digitalization opportunities based on ship propulsion performance, sensor health monitoring, and also the remote onboard diagnostics as mentioned before. Ability to provide server-level agreements with a variety of customers. To get a bit of an understanding, some of our clients, I think many well-known names, both for the Greek market as well as the international market. And then the digitalization. How can digitalization support you with the ship propulsion performance and emissions? To have a clear view on what you want to achieve with the digitalization and data, and for that high-frequent data is very important. The purpose and goal to achieve experience and domain knowledge, and based on this choice, the data set. But the good news is, for ship propulsion performance and emissions monitoring, a limited data set is needed. A bit explanation about which let's say, forces are working on a vessel. Fuel goes in, and out of that you get speed and exhaust gases. Sometimes wind and waves work opposite of the ship as well. And with sensors, we are able to have a view on the propulsion efficiency, engine efficiency, but also on the hull efficiency. It comes in different phases, and when you make it even more detailed, you can see, okay, the fuel goes in to the engine, torque is measured, propeller, thrust, ship hull, which generates ship speed. And for that, we have different levels, 4 levels in total, which level 1 is the so-called bunker delivery. So fuel goes in and ship speed comes out. It's the basic fundamental of using your sensors in combination with the data collection. The second one is fuel goes in, engine and propeller and ship hull, and ship speed comes out. And for that, you need either a so-called PD meter or a Coriolis. You need a data collection, and you can do the measuring, the onboard measuring, consumption per consumer, main engine, auxiliary engines, boiler, and you can create data visualization. And you can do office analysis through our IVY dashboard, high-frequent data collection. We can do in-depth fuel efficiency, automated GHG reporting, and integration with third party, as mentioned before. In our IVY, we can make it visible, so we can create automatic voyage reporting, which also results in CO2 reporting, which more or less looks like this. We can also create CII reports, also coming out of the IVY system. Then we go to the third level, and then you distinguish the engine from the propeller and ship hull by means of the torque measurement. So this creates a next level of, let's say, efficiency checks. For that, you need, as mentioned, fuel meters, you need the torque meter, and also the data collection system. And with that, you can create engine power data, for instance, which is the engine performance measured SFOC of 3 sister container vessels, which you see on this chart. the next one, what you can see is also fuel consumption and engine power data, propeller load curve by adding the T-sense torque meter, and compare the actual propeller power absorption towards new condition. Check the propeller power absorption and find possible heavy running propeller. Yeah, so that distinguishes the propeller from the rest of the ship. Also, engine power data can be checked by using the torque measurement. And let's say we have the highest level, which is level 4, and there we can distinguish the engine from the propeller and the ship hull by means of a thrust measurement. And for that you also need fuel meters, the TT sense, so measuring torque and thrust, and also the SPU3 to collect the data that comes out of these sensors. With that you create additional insight of propeller thrust, which basically means propeller fouling, hull coating, and energy-saving devices, mainly wind assistance, which can be shown on the next slide. This is, let's say, the TT sense applied in a wind assistant propulsion system, because basically what happens if you, the delta of thrust is the delta of hull resistance. So by measuring that, you can effectively measure the effect of the wind assistant propulsion systems. So that's an additional gain that you can create in case you are using the wind assistant propulsion. Here I have some examples of let's say, giving you this insight by means of hull and propeller performance. We did hull cleaning on a ship, and you see the line moving down at the end towards June, July, so you can have an insight of the effect of the hull fouling measured with our torque and thrust measurement. The same is this one, which is the effect of propeller polishing. And you see the line moving higher, so that means the efficiency getting higher, so you can see that the propeller polishing gave a result. We also have that for hull coating, also been discussed in one of the previous speakers. So you really see the big effect measured by the TT sense when a hull coating has been replaced. So that gives opportunities to get insight in the result of these kind of cleanings. So to conclude, digitalization in ship propulsion performance monitoring is essential for fuel efficiency, environmental compliance, and remote diagnostics. We say decarbonization by digitalization, and that brings me to the end of the presentation. So thank you.
I invite Mr. John Kokarakis, Technical Director of Bureau Veritas, to talk on the AI automation and predictive analytics in fleet management.
Thank you, Chairman. Ladies and gentlemen, good afternoon. I invite you to a journey through the transformative world of AI-driven automation and its game-changing impact on fleet performance in maritime shipping. AI is the key that unlocks the value of data. Only by leveraging innovative technology can we secure operational excellence. AI links ship and shore. It utilizes real-time onboard data, hull, engine, fuel, and external intelligence, weather, traffic, fuel markets. Improved routing, lower consumption, fewer failures. They share one enabler. AI makes them possible before humans even see the issue. AI does not replace crews. It augments them, freeing humans to do what humans do best: judgment and leadership. Instead of reacting to alarms, AI detects patterns weeks before they escalate. The crew becomes proactive not reactive. AI converts every day of sailing into intelligence that empowers future performance. It supports main engine fault prediction, leak detection in steam systems, navigation electronics reliability, predictive maintenance across propulsion, HVACs, and even ballast water treatment. The result, maximized reliability and reduced emissions. Quantified benefits validate the transition to AI. Up to 30% less downtime, 5 to 15% in fuel savings, and 25% fewer unscheduled repairs. The early detection capability shifts maintenance from reactive firefighting to proactive stewardship. KPIs are tracked to enabling real-time insights and data-driven decisions. Effective AI starts with robust data pipelines. By auditing sensor data and logbooks, AI establishes a vessel operational baseline, learning patterns and continuously tuning itself to greater predictive accuracy. Traditional reactive maintenance is no longer sufficient. AI-powered models flag anomalies before alarms are triggered, lowering operational disruptions and empowering vessel managers to stay ahead of issues, not chase after them. We shift from trial and error to certainty, from schedule-based maintenance to condition-based excellence. Confidence replaces estimation. Voyage planning harnesses multi-objective algorithms that blend real-time Metosian and operational data and compliance to optimize vessel performance. Human experience must remain at the heart of decision-making. The industry must avoid blind trust in algorithms. The next leap in fleet performance doesn't come from steel or fuel. It comes from data and automation powering decisions and actions. The digital twin revolution enables real-time simulation, predictive maintenance, and enhances asset management by visualizing repairs and tracking performance in 3 dimensions. Bureau Veritas, together with visionary partners, leverages drones and augmented surveyor solutions to rapidly detect anomalies and optimize inspections, all underpinned by AI. With AI-powered tools, inspection footage is swiftly analyzed, potential non-conformities are flagged, and surveyors can prioritize critical reviews. The future lies in AI-powered continuous assurance with live vessel monitoring bolstered by human judgment. High-tech drones gather comprehensive visual data. Through data processing and defect mapping, experts transform remote inspection videos into actionable insights and detailed 3-dimensional models, improving repair planning and asset integrity. Reduced off-hire and manpower. Surveys become faster, safer, more precise, and of higher quality. We move toward smart classification, transparent and traceable. AI identifies corrosion patterns early, predicts progression and recommends interventions before steel is compromised, asset integrity before degradation. The shift from reactive to proactive approach streamlines repairs, ensures compliance, and sustains asset value for the long term. Drones capture imagery. AI converts imagery into actionable findings. Areas needing coating, thickness measurement, or repair scheduling. Objective, consistent, and fast. Input from drones, recommendations from humans. The Bureau Veritas lab in Atlanta employs AI-driven oil condition monitoring, liberating experts from repetitive tasks and amplifying focus on more complex cases. Over 3 million test results underpin the robustness of this predictive capability. The collaboration with Microsoft Azure Cloud has propelled productivity and set a new standard for precision and efficiency in maritime laboratory services. Data-driven testing and classification, cloud-enabled analytics, and on-demand expert tools become a global quality assurance engine across Bureau Veritas, keeping human expertise central to safety and compliance. While technology propels us forward, we must remain vigilant. Cyber attack vulnerability, skill atrophy, potential job displacement, and investment risks all require careful management and continuous human oversight. AI is no longer optional. It turns data into decisions and decisions into value. The destination is clear: smart ships empowered by AI and guided by human insight, charting a sustainable, efficient, and resilient course for the maritime industry of tomorrow. Thank you very much.
Thank you, John. Let me invite Antonis Tsouras, Fleet Manager of Bernal Sulte Ship Management Hellas, to discuss about real-time performance compliance monitoring solutions.
Thank you. Dear ladies and gentlemen, good afternoon. My name is Antonis Tsouras, Fleet Manager of Bernal Sulte Ship Management Hellas. Excuse me. Before I start, I would like to thank Natasha Vasilaki from Newsfront Naftiliaki, Martekma, and its distinguished members for also giving me the opportunity to participate in the Greener Shipping Summit of November 2025. The topic of the presentation today will be real-time performance compliance monitoring solutions from a ship manager's point of view, a crucial innovation that enhances operational efficiency, regulatory compliance, and environmental sustainability in modern shipping. Few words about the Sulte Group and Bernal Sulte Ship Management. The Sulte Group is a family-owned business with a long history in the shipping industry, currently owning 75 and managing more than 650 vessels, consisting mainly of tankers, gas carriers, LPGs, LNGs, bulk carriers, containers, as well as offshore and cruise vessels, offering at the same time value-added services through specialized shipping maritime companies. In today's maritime landscape, the growing operational complexity has become a major challenge for all the technical managers and seafarers. There is a constant increase in the reporting requirements to the shipping company as a start, such as daily reports related to performance, consumptions, bunkering and cargo reports, defects, maintenance jobs performed, etc. Also to charterers, daily voyage reports, in their own format most of the times, to oil majors and to various other stakeholders. Ship managers nowadays need to handle a large volume of technical, operational, and environmental data in real time. So managing this complexity effectively is key to maintaining competitiveness and compliance. Multiple reporting systems often create data fragmentation and inconsistency. Each stakeholder requires accurate information in different formats. Our goal is to ensure data quality, traceability, and standardization across all our vessels. In short, consistent and high-quality data as the foundation for both compliance and operational improvement. So, to address these challenges, we focus on creating a unified compliance framework. This framework ensures data integrity and real-time visibility, enabling proactive monitoring and decision-making. We have already implemented a wide range of tools to support this framework. Some of these tools are shown here. First and foremost, electronic record books, the ER books and the e-logs. This is a maritime electronic record book application designed to replace the traditional paper-based record books on board our vessels. Its implementation across the fleet is a strategic move aimed at reducing administrative errors and workload for our seafarers, minimizing also the risk of MARPOL violations. Entries made in the e-logs are automatically integrated with other modules within the ERP system, eliminating the need of duplicate paper entries. By digitizing the record keeping, ER Books application enhances compliance, improves data accuracy, and streamlines on-board documentation processes. It is important to mention that most of the flag states have already approved the use of electronic record books and logbooks under their respective national regulations, supporting broader adoption of the regulatory alignment. Other major tools, such as voyage planning tool, engine fault diagnostics tools, which is under development, and defect reporting tools, all this data is collected in the ERP system, captured, validated, and fetched in the business intelligence module, the so-called BI tool, providing an overview of operational performance. So, digitalization today is at the heart of the modern ship management. Centralized performance dashboards allow us to combine data from multiple sources, from engine performance to voyage execution. This unified visibility enables faster analysis, improved decision-making, and proactive intervention when needed. It is not just data collection anymore. It is turning data into actionable intelligence. Our integrated ecosystems connects all major operational areas, from accounting to technical, safety, crewing, and performance. So, such an ERP system can accommodate technologies, a wide range of business functions, on a web-based cloud supporting system. You can see also this slide. Yeah, this is all the modules that we have in one integrated ERP. That it's connecting all the major operational areas, and within this ERP we have a wide range of business functions, not only for technical but also for the rest of the departments. It is a web-based cloud-supported system with the purpose of different people in the company with different priorities to function through a single digital platform. Advanced technologies such as telemetry and AI allow real-time monitoring of every vessel parameter. Dashboards cover voyage optimization, hull and propeller performance, fuel consumption, and emissions indicators such as CII. This enables us to enhance efficiency by visualizing performance trends and also establishing our own KPIs. In addition, automated reporting, such as typical charterers' reports, ensuring accuracy and consistency in communication by also eliminating multiple reporting of known reports from the vessel side. This is achieved by reporting data in one platform, which automatically feeds the same data to any other required platform using API as an integration method. Same integration method is also applicable for the data required to be submitted to the verifier with regards to IMO DCS, EU ETS, and Fuel EU reporting. One key benefit of digitalization is the ability also to move from reactive reporting to proactive maintenance. By analyzing defect reports and identifying recurring patterns, we can prevent reoccurrences. This builds a one-stop troubleshooting resource that enhances safety and reliability. It also allows our fleet teams to implement database preventive measures rather than reactive ones. So performance monitoring is no longer just an operational necessity, it's a compliance requirement. Continuous measurement of fuel efficiency, emissions, and maintenance indicators drives both environmental and economic performance. By connecting shipboard operations with onshore analytics, we create a feedback loop that supports long-term sustainability. Ultimately, effective performance compliance monitoring not only ensures adherence to international standards, but also drives continuous operational improvement. It empowers our maritime sector to reduce environmental impact, enhance safety, and optimize life cycle performance, turning compliance from a regulatory obligation into a strategic advantage for the future of sustainable shipping. Thank you very much.
Thank you, Adonis. I would like to ask Mr. Francescos Kontos, Managing Director, AlphaGas SA, for an interesting topic, the pathway to competent crew in the future shipping vs autonomous ships.
Good afternoon to all. Thank you for your participation. I would like to also to thank the organizers, Newsfront, Navtiliaki, and Martekma for this nice event. I will try to cover this subject. I'm a technical person. The subject is mostly non-technical, but let's try to cover it. Let's summarize briefly the evolution of shipping within the last century. We have all witnessed the transition from sail to steam, then to diesel, and recently to electric power and alternative fuel-powered vessels. We have seen that globalization and economic growth drives massive fleet expansion. And also, we know that the integration of digital navigation and AI in the future ships is a fact. The rise of automation and its impact is evident. There is a clear trend towards the emergence of autonomous and remotely operated vessels, which means adoption of advanced sensors, AI navigation, remote monitoring solutions, and predictive maintenance. That necessitates the redefinition of crew roles and maritime workforce skills, and generates the need of a remote operator located at a remote location. There is an increasing pressure for efficiency, safety, and sustainability, dictated by stricter IMO regulations on emissions and safety standards, shift towards LNG, ESDs, including with wind-assisted propulsion and alternative fuels, use of data analytics to optimize routes and reduce fuel consumption, and growing focus on green shipping and carbon neutrality. Autonomous ships, how are defined? Maritime autonomous surface ships are vessels that can operate with minimal or with no human intervention using AI, sensors, and control systems. The potential benefits are related to reduced costs by cutting crew requirements, improved safety through automation, potentially bigger cargo space, and optimize efficiency via continuous data monitoring. The lack of seafarers that we also experience might be also indirectly addressed. The challenges remain in terms of technology reliability, regulatory approval, cybersecurity concerns, and public perception. What we expect in short and the long term? We expect that we have few crewless autonomous vessels within the next decade, and we expect to have some of them in a 20 years time frame, especially for passenger vessels and tankers. It is not expected that we'll have autonomous vessels within the next 25 years. We have already many crewed vessels with automated functions, and we expect to have even more the next decades. How are our crews today? Traditional crews include the captain, officers, engineers, ratings, each playing a vital role in navigation, safety, vessels operations, and maintenance. Experience, specialized training, teamwork, and interpersonal relationships are essential for handling emergencies and ensuring smooth vessel operations, while human judgment remains crucial in making real-time decisions that technology alone cannot fully replicate. Humans are still considered better at handling uncertainties by applying knowledge, experience, and independent judgment. The crew of tomorrow now, how will they look? As automation grows, crew members will need to manage semi-autonomous systems and operate in a hybrid environment rather than perform only manual operations. Future seafarers should be smart on AI, data analytics, remote monitoring, cybersecurity, and maintenance of complex digital systems. Simultaneously, continuous learning and strong interpersonal interaction are needed, such as communication, collaboration, and cultural awareness. Continuous learning and upskilling, reskilling will be vital for the crew in order to stay competent in an evolving maritime landscape. While streamlining operation and reducing human presence on board, MAS creates a demand for new kind of maritime professionals, the remote operator at a remote location, possibly company headquarters, who could handle, manage, and operate several vessels simultaneously. How training now should be reshaped in order to be aligned with technological developments? Modern maritime training must evolve to include simulation-based learning, virtual reality tools, and digital competence. Problem-based learning is another training option which immerses seafarers in the real world of maritime challenges, fostering critical thinking and self-directed learning. Transitional seafaring skills and hands-on experience remains essential to complement theoretical and technological training. However, maritime institutions should adopt a hybrid model, blending traditional seafaring skills and modern competencies to address the rapid technological advancements. Another thing that we have, the institutions have to focus on is to change the mentality of the seafarers in order to cultivate a lifelong learning ability and continuous learning mindset. This will be very important for their future. The remote operators apparently will need to possess supplementary competencies such as intelligent navigation system of autonomous ships, but also possibly IT knowledge and background. Strong collaboration between industry, governments, and educational institutions will be needed in order to ensure that seafarers will be able to handle the future challenges. Short-term future, how our future would like to be. The more realistic future involves automation working alongside with human expertise rather than replacing it. Human oversight ensures safety and ethical decision-making when technology faces unpredictable scenarios. However, we have to understand and admit that technology can enhance crew performance by reducing fatigue and improving decision support function. Talking for challenges and future opportunities, the maritime sector must address ethical and social implications as automation advances. Trust emerges as a pivotal keyword in relation to safety. Exhaustive tests and calibration and recalibration of each system is absolutely necessary before implementing same on board the vessels. Job security and career development pathways for seafarers should be safeguarded through upskilling and reskilling initiatives. Automation also presents opportunities for new technical, analytical, and shore-based roles within the industry. Breaking down the roles of mast operators, researchers could lead to the development of detailed competency profiles or job specifications that outline the specific technical, cognitive, and interpersonal requirements for different operation roles. The future begins now. The transition to automated and digital shipping is already underway, requiring strategic planning and adaptability. Proactive investment in human capital, infrastructures, and technology will be critical for long-term success. Finally, collaboration among stakeholders is essential to navigate this transformative journey effectively. There is no single path in autonomous shipping. We all have to realize this fact. Thank you very much for your attention.
Thank you, Francescos. Calling Nikos Kakalis, Global Bulk Carrier Segment Director of Lloyd's Register, to talk about Step to Efficiency, data-driven condition-based monitoring.
Mr. Chairman, thank you very much for the introduction. Ladies and gentlemen, good afternoon. My name is Nikos Kakalis, Global Director for Bulk Carriers in Lloyd's Register. Thank you very much to Newsfront Nautiliaki and the Martecma for the invitation to be with you today. Another presentation related to technology and going a bit in more depth about condition-based maintenance, taking the the word from my good friend John Kokarakis that touched upon predictive maintenance before. So today I'm going to present a snapshot, a consolidated snapshot of a series of projects that we run in Lloyd's Register around data-driven, condition-based maintenance. And I will try in the next 10 minutes to give you a summary of this on this very, very interesting topic. So, actually, effective maintenance is critical for securing safety and for operational efficiency on board our seagoing vessels. And it's very well known to all of us that a well-maintained ship experiences fewer unexpected failures and breakdowns, as well as proper maintenance improves fuel efficiency and reduces operational costs. Condition-based maintenance now optimizes vessel care by scheduling maintenance based on actual condition of the equipment and enabling more efficient allocation of resources. Going one step further, data-driven condition-based maintenance leverages advanced data analytics and advanced data modeling techniques to enhance things further. The current maintenance practices are very well known to all of us and work very well, quite well. We are very familiar with those. And at the same time, they offer significant opportunities for improvement, eyeing at the limited direct integration among the various stakeholders that are engaged when it comes to maintenance and limited shared data platforms as we speak today. So, traditionally, maintenance is focused around scheduled inspections, subjective assessments, where the human element and the engineer judgment comes into play, quite often reactive rather than proactive maintenance, as well as underutilization of the available technology. So we have a lot of data on board our ships, our modern vessels, but quite often not all the potential from the data that we collect is utilized, is realized. So the last thing that I would like to mention is that also classification societies, we require the collection of a lot of data to ensure compliance, and these data remain on board, and are being accumulated on shore. These data are actually sitting there without delving into this, without making an effort to try to understand and try to develop valuable insights from this data. Sorry. Now, therefore, there is a real room for improvement in implementing effective condition-based maintenance systems and schemes. And one way to address this is by incorporating data-driven analytics into the maintenance workflows that we have, with the aim to enable improved reliability and operational efficiency. And in the next slide, what I have gathered is actually a set of 3 + 1 challenges that we faced in traditional condition-based maintenance, and how these could be improved via the use of advanced analytics methods. So the first is the imprecise maintenance and inspection protocol. So quite often, this could provide lack of precision, leading to excessive tasks or omission of critical activities. So in this respect, analytics-driven approaches using historical and current operational data to refine and optimize maintenance schedule can really provide some additional help. The second challenge is the deviation from scheduled maintenance and inspections that sometimes can happen. And here, the use of data-driven approaches can provide implementation. Can provide use and implementation of digital platforms to track and accurately record maintenance activities, enabling the very automated tracking systems that we would like to have in place. The third challenge is related to the accuracy in terms of condition assessment, sometimes including vague or undefined criteria for hazardous conditions. And again here, the aid can contain data analysis to uncover trends or early warning signs of unsafe operating conditions and potential system failures. And last, I said, is 3+1, is the insufficient troubleshooting response. So in other words, a lack of structured response strategies for failures, something that needs, to my understanding, better development, more R&D efforts, and more consolidated effort to develop something like that. The backbone of data-driven analytic systems and protocols actually is the technology that is behind the frameworks that have already been applied in the aerospace and defense industries quite successfully for several decades now. And actually what we try to do in shipping is to transform the condition-based maintenance, mimicking what happened in aerospace and defense a few years ago. And allow me to say, coming back also to the very interesting presentation by John before, we have just started scratching what we can do with AI and with data analytics. The potential for shipping is absolutely massive, and we are not there yet. So what I'm discussing today actually has at the backbone machine learning algorithms that can now be trained on data sets representing diverse operating conditions. So not only one condition, so the data sets so the algorithms can be trained in transients, in various, all the typical operating conditions that our ships are going through. So these algorithms then integrate monitoring, so data that are coming from monitoring systems, as well as logical reasoning capabilities to assess the equipment health. And other AI and software-based technologies like edge computing bring algorithmic execution closer to the source, improving significantly efficiency. So the technology development pace is getting faster and faster. As I said before, just now we start scratching this very field, but the development costs for machine learning models have started being significantly decreased. And this is very important in order to be coming up with techno-economically feasible solutions. So what drives all this development and the benefits for ship owners and ship operators? Obviously, cost efficiency and profitability, environmental regulation, so I mean reducing via better controlling maintenance, reducing fuel consumption and emissions is very important, also for environmental compliance, as well as ensuring that we have safety and risk mitigation in place. And finally, achieving another level, higher levels of transparency, which is also very important.
1 minute.
Thank you, Mr. Kriezi. So I'll try to speed up, because this is the most interesting part. So here I would like to share with you some data that are becoming available from a project we run with a company from outside Greece that operates 800 ships. So utilizing together with Lloyd's Register these data-driven approaches, we have started quantifying in terms of dollars the OPEX savings for different categories of expenditure, including lubrication, special surveys, repairs, spare parts, and docking. And the ships are categorized according to the age, from 5, 10, 15, and 20 years old. And the older the vessel it becomes, it's quite obvious that the higher the benefits in terms of saving money from the OPEX during the maintenance and the resulting repairs, dockings, and so on and so forth. So, all in all, we are talking about the capacity to have transformative benefits for the maritime industry, and also to enhance predictive capabilities, provide with optimized resource utilization, as well as analytical insights for vessel operators. I'm sorry for rushing, but in the interest of time. And this is my last slide. I would like to say, connecting also to what Francesco said before, that the maritime sector is currently facing a true transient period, being driven by decarbonization objectives and digitalization. So digitalization is here. So this environment provides a unique opportunity to consider implementing data-driven, condition-based maintenance processes and applications that can benefit all stakeholders. Ship owners achieve substantial return on investment through optimized maintenance and reduced downtimes. Classification societies, even ourselves, coming up with improved inspection regimes and compliance processes. OEMs increase the value added and strengthen customer relationships. Cargo owners enhance predictability in supply chain timelines, and insurance and finance gain greater confidence in vessel condition assessments. And I'd like to close saying that all stakeholders are encouraged to explore and leverage such technologies so that we can, all of us together, unlock efficiencies, reliability, sustainability across maritime operations, and benefits in practice. Thank you very much for your attention.
We have some time for questions. If there are any questions from the audience. Yes, go ahead.
Thank you, Mr. Chairman. For those who don't know me, Alex Karkantzos, former chairman of an IMO committee, I would like to discuss a little bit about the AI. AI is a reality. The genie is out of the box. There are many dangers there, because either we will control the genie or the genie will take us into the bottle. So we need governance. Standardization is the first step. But there are many others which I don't know. Perhaps you know. Someone might suggest more.
First of all, I would like to make a statement on AI. AI is nothing new. What is new are the chatbots. This is what is new. 40 years ago, we applied my other life. We applied predictive maintenance, trying to find out when a liner will fail. So what we did, we had thousands of data on liner wear from various sister ships. A statistician passed a probability distribution factor, checked its fitness with a goodness of fit method. This is something that probably the AI could do, the chatbot. And then we predicted when the wear will exceed a certain value. The company said, we don't care to replace the liner, but we have to know when it will happen. So predictive maintenance is very important and has been applied long ago. As you noticed, Mr. Karkantzos, all of the guys that spoke today about maintenance and AI all mentioned that human oversight is necessary. When you talk to an AI, you have to tell it exactly what to do. A lot of times AIs make mistakes, terrible mistakes. They send you to a different pathway. So you must check the answer, ask the question again in a different way, otherwise you run the risk to have wrong answer. All the graphics I used in my presentation were done by AI. But you just don't say to the AI, to the chatbot, do this image, you have to tell it exactly what to do. And then there is the beautification of the image. So always oversight, because the real leadership and insight comes from the humans. I have solved differential equations utilizing the chatbots. It is tremendous progress, and it utilizes the power of the computers. I believe we have to continue using them, but not too much, because, as we mentioned, our skills may become atrophic. We might lose our skills. This is another risk. So from time to time, we have to do it by ourselves. Thank you.
Any other questions?
Hello, I'm Alex Valdagis from Cross Technical Services. About technical skills atrophy, how can one regulate it, and how can you know when you might exceed it and be in the danger zone, of lacking the technical skills because you rely too much on AI? Thank you.
I don't think that there is an answer as we speak to this question. It will be, let's say, a question that should be answered in the future. We have to realize that the regulatory framework is still very weak. We have not even the code for autonomous vessels. It's something that it is going on, and we expect to have a version ready by 2030, not even now or next year. So we all understand that all these things are quite new and have to be addressed in detail and with the luxury of time. But as an indirect answer to your question, we can assume that it's the same problem that we face nowadays on board our vessel with the application of certain special navigation tool, like the ECDIS, for example. So how much we rely on the equipment and how much we rely to the watchman judgment is still on the gray zone, even today on board our vessels. We all know that because we face all the problems that we might have from inadequate watches or insufficient attention to targets and so on. So more or less is something that we are still facing. I think that how this will be regulated, it will be very difficult. And what I can foresee also the tests, there cannot be no tests that can assure anyone that you have exceeded this limit, as we speak at least. Thank you.
We have time for one more question. Anybody? Would like to ask something?
Not a question, but a note to last presentation of Mr. Kakalis. I think it was, even for the 5 or 10 years, for the spare parts with condition-based maintenance, we could see a difference there in the finance. This is what I believe. There would be a difference. There would be a beneficial difference there.
Gregory, thank you very much. You are right. First, just to say that these data are being collected as we speak. So the more data we populate with those diagrams, the more insights we can deliver. So definitely there should be some difference and some benefit when it comes to spare parts. But the biggest difference and the biggest gain is from saving money from unexpected shutdowns and failures and damages like that. So improving the control you have on board the ship in a proactive and preventive manner brings most of the financial benefit.
If I can add to Nikos' answer, is that I totally agree that the cost benefit will derive from unexpected maintenance, because on the other side we still have tools nowadays to do, let's say, predictive maintenance, especially on main engine. But what we see is that main engine makers put a limit, so you cannot extend the life for a component of, for example, a liner or a piston rings indefinitely. You have, let's say, at maximum every 5 years to proceed with overhauls, so the expense is there. And the answer is, the justification is that fatigue cannot be predicted. So in order to save from fatigue phenomena, you have to proceed with overhauls. So I fully support the opinion that the cost benefit will come from the unpredicted maintenance.
Thank you very much for all the panelists. We will continue with our fourth session, and we will not have a break. We'll go immediately to the next session. I invite the panelists to join me here. Our last session will be the market voice, political tension, and environmental regulations complexities that will go beyond the environmental intent. I would like to invite Mr. Kotsias, co-founder of Exclusive Shipbrokers and president of Hellenic Shipbrokers Association, to moderate this panel. And I would like to invite the panelists to join me here in the podium.
Good evening, ladies and gentlemen. Natasha, thank you very much for giving us the privilege and opportunity to set up this excellent panel with distinguished speakers. I will introduce each speaker very briefly. On my left, John Platzidakis, honorary chairman of Intercargo, and collective and vast experience in managerial in shipping, and he will give us a very nice insight of how the geopolitics are affecting the regulators, and vice versa. On my right, Miltiadis Varvitsiotis, Vice President of and Chief Executive Officer of Skarmangas Shipyards, and of course, two-term Minister of Insular Shipping and Insular Policy. So he has two hats that he can share today with us, explaining how the shipyards revival in Greece is moving, and also how the policymakers' opinion on what we see very current today. Next to Miltiadis is Panos Zachariadis. I don't think we need to introduce at all Panos in any forum, in any conference. His voice is always very interesting, and his opinions is always very interesting to hear. And last but not least, Panagiotis Panos Zafet, Managing Director of Baltelas Group. He will also give us the perspective from the owner's side and how the commercial impact of all the geopolitics and the latest developments that we saw in IMO on the policy making of decarbonization are affecting the commercial decisions of a ship owner. So it's very interesting to have practically from every different aspect a very vast topic which has more questions, I would say, than answers. Unfortunately, this is what we face. I think we can rephrase the title of this panel into political tension and environmental regulations when intent actually meets reality, because we're coming down to reality. It's only 2 weeks ago that the IMO deferred the net zero framework. This is probably a reality check that shows good environmental intentions that often collide with geopolitical and market realities. This is very important. Only last week as well, US and China, they canceled the reciprocal tariffs, meaning and giving us a reminder that shipping finds itself very much at the intersection of trade politics and environmental policy. Today, we will address questions depending on who is more capable of handling these difficult answers that we will try to get. I will start with John. John, you have actually shared for 3 terms, if I can recall, President of Intercargo. Indeed. I think from 2013 to 2018, and during that time, if I can remember well, there was a proposal that you had well thought of proposing like a levy on the fuel directly. Something that today we see that the levy doesn't go on the fuel but goes on the emissions. And that was an idea that sounded rather interesting. And going back to it, I would like you to refresh our memories on that proposal and what happened to it and what was deeper, some, politics as well.
I would like to refresh my memory as well, if I may. Well, at that time, it was more or less the beginning of IMO getting a lot in depth in emissions regulations. And we were trying to figure out what was happening. The IMO was taking measures at the time without any consultation with the shipping industry, which is understandable because IMO, we will say that later on as well, it's a political animal, so there was no need to address any question they had to the actual players. Nevertheless, there was a consideration of how to make more efficient ships and reduce the CO2 emissions. I think it was a rather practical approach that we adopted at Intercargo at that time, that we had to make the users of the ships, the charterers, more concerned about the fuel efficiency of the ships. As we all know, it is more or less the charterers that emit. It's the charterers that pollute. The reason is that we provide the asset as a shipping company, as a ship owner, and the charterer, unless there's some weird charters, but in general, it's the charterer who dictates of where the ship will go, at what ships, at what speed, and exactly what to do. So we came up with a proposal that the more practical way to control the CO2 emissions was to put a levy on the bunkers. There were several parameters in that decision. First of all, let's look at how we operate in our day-to-day life. We, more or less, all of us have cars. When we fill the tank, automatically, we pay the tax, right? So we pay 1.70, let's say, per liter. €1 goes directly to the coffins of the state. The car owner, the car driver, does not get involved. The government collects the money, and they do whatever they want without asking us, and we don't want to be asked. That's it. On the other hand, the typical economic theory says that supply and demand are dictated and define price. So by putting a levy on the price, a levy that is to be decided by the government, by the IMO, somebody, you can dictate the consumption of the ships because you make the user of the ship, the charter in this case, more concerned about an efficient operation. The same applies to the car owners. If the government increases the taxation on the gasoline from €1 to €3 and we pay $3.70, we will be more concerned of where we go. We don't take the car and driver out without any purpose. So that's why we said it. And the end result would have been, had it been adopted, that the ship itself would not get involved in this tax collection mechanism. It would have been adopted by and put on the shoulders of the person who buys the bunkers. In that case, would have been mostly the charterer, right? So by doing that, first of all, we were putting the charters on the spot because they buy the bunkers, because they want to burn the bunkers, to consume the bunkers, and therefore they create the CO2. So the polluter pays, and the ship was immune in this theory. Anyway, very briefly, I presented to you the philosophy behind that. Regrettably, when we put it at the round table, it was not accepted, saying that it's too early to discuss about it. We have to discuss it sometime in the future. Nobody could address the question when in the future. Nobody knew, and what would happen between then and the future date, again. So it died away. And then the result, as we can see today, is a mess. We invented EEDI, EEXI, CII, net zero, research and development funds, you name it. You need a whole Bible to remember what all these acronyms mean. Anyway, that's history. Thank you.
History sometimes is good to go back and to see how we can apply history into the future. But you said very rightly, sometime in the future, nobody knows when. Maybe it's the right time now, maybe it could be revisited. What it would have given as a benefit is that it was going to be a global and not a fragmented regional penalty, as we call it, because it is a penalty that people are paying who pollute, and at the same time would also be applicable to ships of all different types. Anything that burns fuel and buys fuel would pay it. So that means not in the ships of 5,000 GT and above, which is the IMO proposal. Anyway, John, maybe you can reinstate that. Maybe that's something that can happen.
It's too late now.
It's too late, maybe. I agree. I would like to move on to Miltiadis Varvitiotis. We are actually led by the news making of last week. So, as this conference has been preparing for 2-3 weeks now, geopolitics are really catching us by surprise. What we saw lately, and I would like your opinion, both as a politician and both as a shipping technocrat. Recently, Greece has entered a new chapter in its strategic cooperation with the United States through ExxonMobil, Energean, Hellenic IQ, the agreement for hydrocarbon exploration in the Ionian Sea, and also it was coupled by the strengthening of LNG transportation and infrastructure links. From your perspective, how do you see this influencing Greece's maritime and geopolitical posture, not only in the years ahead, but in the weeks ahead? Because I think this has put us on the map very strongly.
Well, thank you, John. It's great to be here, and it's great to talk about all these geopolitical changes that actually highly affects the shipping industry. So far, the shipping industry was a little bit, remote from what was happening in the world. And nowadays, shipping is highly interconnected with what's happening in the world. And I'm saying that because for the first time, maybe Yannis knows a little bit better than me, but I don't remember in my 25 years being involved in public life and following shipping, another period that Greece has been actually welcomed by a major player like the United States, the most powerful nation in the world, based on its shipping capabilities. It is the first time. It's unique. The strategic importance of shipping was always talked about in the Union of Greek Ship Owners, at the events in the Marine Club, and this 250 meters was the only area that there were people willing to listen to the geostrategic importance of shipping and how Greece is becoming relevant because of its shipping. It's the first time that the US government is coming in Athens, meeting most of the Greek ship owners, or the many high-profile ship owners, and stating that, listen, we want a strategic alliance with Greek shipping. Why? Because for the first time they realized that instead of being a net importer of energy resources, they are becoming a great exporter of energy. and they need a reliable partner with whom they can carry their goods around the globe. The second thing is that Greece is becoming a hub, something that we actually weren't thinking a lot about. Now Greece is having already the Revithousa LNG plant. It has the FSRU in Alexandroupolis, and start to build the third station in Komotini, another FSRU that actually, and that means that we are going to welcome dozens of ships every year carrying LNG, US LNG into Europe. And the final point is that for us, it's becoming very important to realize that, and I follow up from what you have talked with Jens Platsidakis before, about the role of IMO. I was a keen supporter of the IMO. When we held the EU presidency back in 2014, I welcomed the General Secretary of IMO to the ministerial meeting of the shipping ministers of European Union in Athens, and I said, we should go along with IMO in imposing regulations. It didn't work out. Europe has imposed its own ETS, and then actually guided the IMO to come with this net zero framework without saying that it's going to lift its ETS if the net zero framework was going to be imposed. So double taxation for the same thing. And what they like to understand is that their approach was, on behalf of IMO, it was very logical because IMO was getting a global application of the measures, but it was getting also a lot of money, without saying how they are going to distribute this money that they will get out of the net zero tax, and who are going to be the recipients of that. Are there going to be the shipping companies? Are there going to be the countries? Are there going to be the people? We are talking about billions of euros, billions of dollars coming in to an organization that has no experience on how to use money. It's not like European Union that actually distributes 1 trillion every 7 years. It's the opposite. And the last point was that they didn't realize that the exclusion of LNG as a fuel would actually create the opposition of the United States that envy the position of being the #1 exporter of LNG worldwide. And this went down the drain. It hasn't been deferred, in my opinion. It went down the drain. Nevertheless, and I'm closing because I talk too much, I think this is a great challenge for us. It is also a great challenge for the Greek shipyards. The fact that Skaramagas next year is going to be certified to service LNG carriers is a great thing for us, that we are going to have so many LNG carriers coming into our region and actually Greece becoming extremely relevant for the US exports. This means security, this means jobs, and this means leverage over our beloved neighbors as well.
Miltiadis, thank you very much. Just to add to what you said about LNG, I was a witness in late March of 2025, the Greek delegation initiated by the ministry. We went to the European Bank of Reconstruction and Development in London, and we had a conversation with stakeholders from Greece as well for the PPP of funding Greek vessels for the for serving the remote islands. And one of the discussions that was put on the table, and also I personally put this question, why are you excluding LNG from the alternative dual-fueled vessels, which are a possibility, especially in the ROPAX business? And the answer was from the European representative, a lady who was present in the meeting room, and she said, no, it's a fossil fuel and we don't like fossil fuels. I mean, that was, not a check mark on the alternative fuels. It's not a fossil fuel. Now, coming down to LNG, the best pass that I can give the assist to Panos Zachariadis. Panos, you've always spoken candidly about the dangers of rushing into unproven fuels, and I think it's a good opportunity that the IMO and ZF delay that could vindicate your call for evidence-based transitions rather than politically driven ones. Do you think that it would have been better for shipping if it had passed, or is this deferral actually a blessing in disguise? And I would like your opinion on that, because I know you always have very concrete evidence on what you say.
It's definitely a blessing, and it's not in disguise. It's a blessing, period. And I hope it goes a longer way, because I want to say a few things about IMO, because I've been going to IMO for 15 years, maybe even more than our previous head of delegation, Mr. Karkajos. I started when he was our chief. Sorry. So, IMO used to be a rather technical body of IMO. You could make, of course, diplomacy was always in play, because every country tries to support their industry. I mean, Japan and China want to support their shipbuilding industry. Greece wants to support its own industry, which is shipping. And the interests are not always the same. We want, for example, strong ships that we don't need to repair too often. But that's exactly the opposite of what the shipyards want, because that makes the ships more expensive for them to build. So there was always those kind of things. But we always had technical arguments. At the end of the day, the technical arguments would win. This is how we were able to reverse the decision that was taken at approval stage, similar to what happened now. They wanted to make all bulk carriers double hull, because it was good for tankers, therefore it should be good for bulk carriers, which has no connection with the technical arguments. We won the technical arguments, they took it back. Lately, however, IMO is not a technical body anymore. They make regulations that have no basis in science, right? They make regulations because mostly the European Union thinks it's a good idea. And not only that, what we discussed before, when I was at IMO, there is a regulation of the European Union that if there is an active regulation in Europe and a similar thing is being discussed at IMO, all member states must support the European regulation and try to make the IMO regulation as similar as possible to the European regulation. And if I deviated from that, then the commissar of the EU, that's always there, would go to the head of the delegation and say, tell this guy to stop, or I'm going to call you minister. That's exactly what happened. So what I had to do is I had to use tricks. I had to go, for example, all the work happens in the working groups. I had to go to my friend from Brazil and say, listen, when paragraph 8 is being discussed, you raise your card and you say this. And then I go to my friend from Vanuatu. Listen, when Brazil says that, you raise your card and you say that. And then this happened, and then I would say, oh, new information, we didn't know this. This is serious, we have to examine that. And that's how I was able to bypass the agenda of the European Union within IMO, but you can do that only so many times. So what happens now at IMO is, I believe, the European Union has hijacked IMO. Listen to this. Fuel EU gives credit to the LNG. According, therefore, to the European regulation, it should be the same thing at IMO. Yet they go to IMO and they say, no, we penalize LNG from day one. And that's, of course, the main problem, that this regulation. I mean, what they did to me, that they say the commissar would go to the head of the delegation, they didn't comply with their own regulation. They went to IMO and they wanted to be, as we say in Greek, Vasilikoteri to Vasileos. We have this regulation. It's okay for LNG in Europe, but it's not okay for LNG in IMO. And that's what destroyed this thing. And it's a good thing that America had this reaction, because this was the excuse we wanted to delay and hopefully bury it, because it's not based in science. These green fuels are not going to be good for the environment as they're advertised to be, but that's a different discussion. But I just wanted to touch on the politics of the issue.
If you allow me, John, to say that the State Department announcement about the net zero framework, it's very funny. At the end it says, the United States will be moving to levy these remedies against nations that sponsor this European-led neocolonial export of climate regulations.
Not far from...
Well, superpower, planetarchis as we call him, he can say what he wants and people can follow him. The news actually come very fast, and today, just as we are here in this conference, we have an official announcement that the Houthis have paused maritime attacks on Israel and lifted their so-called naval blockade on Israeli ports. So this announcement just appeared on a letter sent to Hamas's military wing by the newly appointed Houthi chief of staff. Panos, Zafet, I think that being a ship owner, you manage commercial risks every day in your daily, not even daily, nightly as well. Shipping 24 hours, 365, of course. How do you plan your investment strategy and in general your operational strategy amid this policy whiplash? When one week we have decarbonization deadlines, next week we have deferrals for 1 year or for more, then tariff pauses for a year or less, or this can change. Now we see also the Houthi red zone area becoming less of a red zone area. What is your feeling in general? How do you manage all these uncertainties and risks?
Thank you, John. First of all, I would like to thank Natasha Vasilaki and Newsfront Naftiliaki for the invitation, the kind invitation, and also Martekma. It is an honor, a privilege to be among such a distinguished panel and such distinguished guests here. The first rule that we all learn when we enter this highly competitive arena of shipping is that that's at least what we used to learn, was everything is based on supply and demand, which means tonnage availability compared to the cargo volumes expected to be transported in the next year. The second rule, of course, that we have all heard of was cyclicality of the market. Even in the end of last century, the predictability of a cycle, of the market cycle, be it upward or downward, was difficult to predict exactly, but the typical cycle was 3 to 4 years. This used to be the norm. And later on, it was replaced by far longer or shorter uptakes or plummets of the market. But that's all in the past. Now we have gone back to the ancient Greek philosopher Heraclitus saying that everything flows. Nothing remains the same. Nowadays, it's even more precarious to make decisions based on the so-called fundamentals, given a continuously changing environment due to environmental governance, ongoing conflicts that, of course, cannot be predicted, piracy, and, as we already mentioned, a very foggy regulatory regime that changes overnight. So you mentioned the example about the Houthis today announcing that they will stop the attacks against Israeli ships and commercial, let's say, activities in the Red Sea. However, 2 days ago, we had an incident of a Greek-owned vessel which was hijacked by Somali pirates. We were considering in the industry that this was a danger that did not exist anymore. It did not exist anymore, but this happened, and it only happened 2 days ago. So what we have seen is that we have to be prepared against the unpredictability of events, geopolitical, be it, or you name it, tariffs, or whatever there is. The shipping industry has proven its resilience, flexibility, and adaptability by adopting and integrating different requirements as regards, for example, fuels like very low sulfur fuel oil, by adopting energy-saving devices, digitalization, route optimization, things that the previous panelists talk about. Right now, we are really on moving sands. We are really stepping on moving sands. I'm afraid it is difficult to be one step ahead of regulators, as there's a clear desire between politically motivated regulatory decisions and pragmatism. 2 weeks ago, I was in a conference in Shanghai, and a very known Greek shipping figure, Mr. George Prokopiou, stated there's a difference between desirable and doable. For everyone, the notion green shipping is something very attractive, and we all would love that shipping transitions in this era. However, there is no proven technology to support a green transition, let alone the necessary infrastructure. Just imagine a bulk carrier having to take bunkers in West Africa. How would this be possible to get green fuels there? It's just an example. Vessels do not have specified routes except perhaps for some LNGs or containers. Otherwise, the routes are something that is defined according to each fixture. What we see as a major danger right now is the fragmentation also in the policies adopted by certain countries. We saw that the Fuel EU and ETS has already been adopted, although other countries have not taken such measures, and this is setting a dangerous precedent because, especially now that the IMO decisions have been postponed, it means that many countries can take arbitrary decisions on the regulatory basis and implement taxes and levies on shipping. This is not unique. I will give you another example that shows the complexity of making decisions nowadays in shipping. A few days ago, we fixed one of our vessels from Australia with a major charter going to Far East. The fixture finally did not get the subjects from the shippers. The reason was that our vessel had called in the beginning of 2023 in Russia. But she called Russia and she loaded a cargo of grains, agricultural products, which is a cargo which is not sanctioned. And this cargo actually was from World Food Programme. It was a humanitarian aid cargo. So the vessel was rejected, however, by the shipper. The shipper decided that this is not a vessel we want to fix. 2 days later, we fixed with another Australian cargo, with a different port of loading and a different charter and a different shipper. The vessel got all her subs. Actually, we're quite lucky because the rate was even better. But, I'm just saying that there is such a lack of visibility when it comes to political decisions, politically motivated decisions. You see one shipper and one insurance company not taking the risk in the same country of fixing our vessels, because in January 2023 she had loaded ex-Novorossiysk, and then you see another shipper saying that it is okay, you have disclosed all the information that we asked you for, we saw that this is an agricultural product, so there's no problem. So how can one make a judgment that can be safe? It's a clear indication of the absurdity that we are facing nowadays. and things are constantly changing. What one has to do is to stay ahead of these decisions by taking normal precautions and act prudently. That's the only thing we can really recommend to any ship owner, and this is what we are doing.
Pano, thank you very much. Very important points, and also the ambiguity that exists is not only something that you're facing, but we as brokers, we receive it from a lot of principals, a lot of owners, and creates a even more uncertain environment to operate in. John, I would like, because you have a good, strong voice, always, and whenever I hear you speaking, you always catch the audience. Is Greek-speaking owner voice? And I put into Greek-speaking Greece and Cyprus, because Greece and Cyprus actually were together in this IMO meeting. And the Cypriot owners also led somehow this deferral. But is this Greek-speaking owner voice now a strong voice worldwide? Do they listen to us more?
It's too political. Typically shipping, worldwide shipping, does not have political weight, regrettably. If you look at the beer industry, for example, in Belgium, they do have political weight. If you try to change the status that the beer industry works in Belgium, you're in trouble. Shipping is not as such, because the major powers, with the exception of China, don't have ocean-going ships, mostly. So it is Greece and Panama and Liberia, etc. It's not the US, it's not the UK, it's not France, not Germany. So we cannot influence the political decisions. And in the case of IMO, it is a political animal, as we said earlier. The 108 Marpol Chinese signatories a few days ago are representing their own government. So they get the message from the Ministry of Foreign Affairs: this is what you will be doing tomorrow when you come to net zero voting. The various associations are not part of it. And I'm sure that all these people don't know much about the various organizations, regrettably, and they don't read the press in order to decide what to vote the following day. It's good that we express our views. It's good that it got all the publicity, but let's be realistic. The reason that it was deferred, the decision for net zero was deferred, and to my opinion it was cancelled, is because the US took a stance. And they said, don't you dare, in a very polite and very, very delicate way. If you do, you will regret it. And it was a dead case. It was obvious that there was no chance to go ahead. Of course, I didn't expect to be deferred, but the deferral was also a political decision not to be embarrassed all the way with a total cancellation. So it's good that we have our voice, it's good that we can talk, but there is a limit to that, regrettably. And it's a pity that being part of the European Union, and don't forget that the Greek-owned fleet is something like 60% of the European-owned fleet, so it's a very, very significant part of the European fleet. Nevertheless, the ministers of the European Union don't have much consideration about it, but it's something that we have to work upon and try to achieve whatever we can.
John, thank you very much. It's politics always, and superpowers who can dictate their own agendas, but I think that, as you rightly said, it could have been cancelled, but instead of total failure, it's better to say, you know, yes, let's just sleep it for a while. Miltiadis, being both a policymaker and also a shipyard CEO, how do you see these shifts in general influencing our country's ambition and your company's also ambition to rebuild the shipyard sector I will start with retrofits. I will start with repairs and anything that can enhance the vessels to make them more fuel efficient today, which are quite a lot of opportunities. And also, I would like your opinion on new buildings. And on new buildings, being able to build ships in Greece, as we do and we have done in the past. How do you see these opportunities arising now?
Well, thank you for that question, and I would like to thank two of the previous speakers that actually highlighted the importance of doing a dry dock very often in order to optimize the ship. So I would like to say that it was, music to my ears. Shipbuilding in Europe. Shipbuilding in Europe, at the year 2000, Europe was building 55% of the world's new vessels. 2023, this has gone down to only 5%. Why? 3 reasons. First of all, state aid rules that actually deprived all the European shipyards for any kind of support from the states. Second, very strict environmental rules on shipbuilding, polluting, emissions, all that. And the third thing was the lack of proper financing. And in these 25 years, we have seen that now most of the ships are built in Far East. And to tell you something more, it's absolutely impossible to find a Chinese shipping company given an order elsewhere, while you see all the European shipping companies giving the orders elsewhere. So it's how we reverse that. It's also 3 things. First of all, we have to trust the European shipyards. We are not in a position to say that wages in Europe are very far from the wages in Korea or Japan. I would say it's the opposite, especially if we are talking about Greece. So it's a matter of trust. The second thing is the matter of what are we going to build. Are we going to be a highly sophisticated ship that incorporates all the new technologies, or we are going to replicate a model that has been used and over the years it has becoming a little bit better and a little bit better. And the third thing is how the states and how the European Union stands in front of it. And the European Union has already announced that it's going to present its new policy about that. In Skaramagas, we have been out of the market. Skaramagas shipyard has been out of the market since 2009 by a fine imposed by the European Court. The Skaramagas has been deprived of its commercial repair. The first ship that got in Skaramagas shipyard for repair, for commercial repair, was on end of February last year. Since then, we have welcomed more than 75 vessels so far. And thank God, the Greek shipping community and the Greek ship owners has entrusted us. And I think that we are in a competitive mode, saying that we can offer at the same price that you can find elsewhere, in Turkey, for example, with a higher quality that we may offer in Skaramagas. What we focus on, I told you, LNG carriers, that we are going to be certified there next year, quality, and to be on schedule and on budget every repair we undertake.
Repairs are very important, and it's very important to revive the repairs.
Yanis, I didn't answer about the new building.
I was going to say now on new building something. Which...
I didn't answer the new building. I think that new buildings in Europe should be in special boats, highly sophisticated, and of course, we should definitely focus on the passenger ferry, RoPax vessels that should adapt in these new environmental regulations that apply in our ports.
I would like to give you something which comes out of practicality, and maybe you can address it and maybe you can find a solution. Maybe this would lead you into being able to attract more orders, or orders, not more, orders, and then more orders for new buildings. The lack of refund guarantees is a serious issue that somebody who would like to support the Greek shipbuilding and build a ship, and specifically I can tell you, aluminium catamaran for passengers, which is something that we need to replace the passenger vessels, the RoPax. The reasons that you cannot choose, even for a Greek owner, I'm talking about a Greek owner that doesn't choose Greek yard to build it, is because the yards don't have the ability to provide refund guarantees. And maybe an idea would be a state-backed refund guarantee that could be provided to owners who have the financial backing, meaning they have the money to order the ships, and at the same time they need to feel secured for every payment that they do, that it's backed by a refund guarantee from an established organization. Some solutions that we find is going to Lloyd's market and getting insurance guarantees. This is other European countries that do that, like in Italy and in Croatia. But if we are pioneers in this and we can establish a refund guarantee which is backed by the state, maybe, Miltiadis, you can discuss this idea, because that is a serious lack of security. That owner needs security. If the yards are established and they have provided a flow of vessels, that security is less important. But now, to get the ball moving, this is more important. So just a note on this, and maybe, you know, out of this conference we can become a bit wiser, and maybe we can get some steps ahead.
Well, refund guarantees, that unfortunately comes with this state aid framework. How we can overpass it? Because this is what we are thinking and what we try to advise also the policymakers to do, is to actually come back and give the grants that they are giving, to give, especially for passenger ferries that interconnect Europe, and the Greek islands are part of Europe, but I'm talking also the Greeks, Italy, the commuting to Malta and all the other major European islands and between ports. It's important to say that if you take a public service contract, then you can have also a backlog of funding. This would facilitate, because the refund guarantee, unfortunately, is at the core of the state aid rules, and this is very, very hard to bind. To tell you the truth, Stavros Niarchos was asking for a refund guarantee back in the 70s from the Greek state for the model of SD14. It was the model that actually was the more big ship than the Liberty, and then the Greek ship owners started to choose this SD14, 14,000 ton ship. But it never came through. It never came through. It was impossible to pass it, not even that time. So I think that we have other tools. We are proposing them to some of the ship owners that are coming to explore this possibility. And I think that we are going to find somebody who is going to be brave enough to spend a lot of time to actually pass this way and lead the way for more sophisticated EU funding in new building.
Panos Zachariadis, I don't know how quickly you can give us a roundup of which alternative fuels remain technically and economically feasible today, and how should owners prepare amid all this constant regulatory uncertainty?
none of the alternative fuels.
I said how quickly you can answer.
Let me tell you very, very fast why. First of all, we're not going to have them, okay? So it's an academic discussion. What are we talking about? We're talking about green ammonia and green methanol, which you make from green hydrogen. Well, you may have a little bit green hydrogen, but you're not going to have the others. Because just the energy you need to split the water with electrolysis to make the green hydrogen for what shipping requires, you need half the world amount of electricity. I'm not talking renewable, I'm talking total. So it's science fiction. And then you might get a little green ammonia because it's a lot easier to make, because you add to the green hydrogen nitrogen, which is very easy to get from the atmosphere. But green methanol, you're not going to have any whatsoever, maybe a couple of barrels, because the regulators say, in all their wisdom, that to make green methanol, you need to add CO2 to the green hydrogen, but only CO2 which you capture from the atmosphere. And that's a very expensive, very difficult proposition. The biggest factory there is has a capacity of 56,000 tons per year, which is the emissions of just 2 ships. It's ridiculous. So by regulation, they make the green methanol unavailable forever. And I wouldn't touch, personally, green ammonia for my ships. It's totally deadly. 0.7% in the atmosphere, one breath you're dead. I don't think, for example, if a ship with green ammonia arrives in Piraeus, that the Piraeus Port Authority would allow it to enter. But that's a discussion for the future. Okay, let me take it one step further, real quick. Let's assume we had all this renewable energy to make those green fuels, okay? If you use that renewable energy to make our green fuels, liquid fuels, then we all know, as engineers, any fuel you burn in an internal combustion engine, 60% of the energy goes up the stack as heat. Only 30% eventually goes to the propeller. That's the problem ships have. And airplane turbines are not much efficient either. They have an efficiency of 30%. So the kerosene, most of it goes to the exhaust, and only 30% turns the propeller of the airplane. That's the problem with liquid fuels. So you use all that precious renewable electricity to split water to get the green hydrogen, to add nitrogen or CO2 from the atmosphere to make the methanol. You take the methanol, you burn it on the ship, 20 to 30% goes to the propeller. You wasted 80% of that renewable electricity to make those liquid fuels. That same electricity, if you charge a car, an electric car, 95% goes to the wheels producing useful work. So why waste all that renewable electricity to make green fuels when you don't have enough? You should give it to the grid or power electric cars or trucks or trains where you can use 95% of it. Because if you do it to make green fuels, then you have to replace that electricity for the other stuff. And since you don't have enough renewable, you are going to replace it with fossil. So all these regulations at IMO is you pay for something which you're not going to have ever, but if you had it, it would be bad for the environment. So that's my problem with IMO regulations.
Panos, thank you very much. Always elaborating on your findings. I find it very interesting always. It's true that a lot of the alternative fuels even if they don't come down to the economic merit of how you operate with an alternative fuel, how expensive it's going to be versus the fuel that we know, only the risk to the seafarers, to the ship and the seafarers, which is the most important. Without the 1.8 million seafarers, all this 90% of cargoes that go through shipping would not be possible. So we have to think of the souls that work and operate on the ships above anything else. Panos, Zafet, you also believe today, as the ship values, some can say that they are decoupled a little bit from their earning capability. The ships are expensive. I mean, this is what the general consensus says. We have come through the years of post-COVID, and we have come through the years also of February 22, Russia, Ukraine. So both tanker owners and bulk carrier owners have made money out of this 4 or 5 year period, and the values of the ships have remained higher than needed. Also, the new building is expensive. With all these uncertainties today, how can you have your strategy of investing? I mean, would you invest in today's environment, or there are many deterrents, like expensive ships and risks?
As you rightly pointed out, the markets seem to be decoupled in terms of prices of the assets, as opposed to freights and hires that can be achieved. We saw this in the beginning of the year, especially with the bulk carriers that had very lackluster rates obtained. However, the prices did not fall significantly. They only fell by about 5 to 10%. And then there's also decoupling in terms of the age of the ships, because the more modern units tend to have a very strong market price in the second-hand market, as opposed to the older units, which have a good value but not as high as the 10-year-old ships. So right now there's so many uncertainties that we have already touched upon. Geopolitical events. We're not sure what will happen if the conflicts end right now, and if the ton miles will be reduced. Because let's not forget that in 2025 we anticipate that about 0.5% of the growth we saw on the global trade was due to the ton miles, the extra ton miles, due to the problems that we all know at the Red Sea and vessels having to go through Panama Canal. So there are a lot of uncertainties, and prices are on the very high side. It also depends where you are standing from. An owner with a big fleet should definitely invest in order to renew his tonnage, and probably for them the best solution would be new buildings, because right now we have about 28% of the world fleet aging, over 16 years of age, and there is a problem, especially in terms of their speed and performance, as most regulatory bodies are looking for better performance. So, in other words, it depends where you come from. If you are a medium size or a small owner, you should wait for the right opportunity right now, or be very ingenious in terms of the financial method you are going to use in order to buy a ship. We all have heard of Chinese leasing terms, or JOLCOs, or different kind of financing that is that has appeared in our shipping environment, and you have to be creative. You must think outside the box and be ready to take advantage of these financial opportunities that might arise.
Indeed, very interesting. We always see that in shipping, pragmatism and being realistic has been our compass, and I think this is something very important. Just a note that after we heard that USA and China more or less agreed not to fight each other with tariffs and counter tariffs and charges against other chargers, and penalize USA controlled vessels against Chinese controlled or Chinese built or Chinese operated or Chinese financed. Of course, what we hear in the morning from USA might be always recalled or changed in the evening. That is, I agree very much with that, but it led to a lot of owners going and ordering, mass ordering of dry bulk. We saw that in the past 5 days, 10 days. 6 orders for FNAV, Ευσταθείου, 6 orders for Kamsarmaxes, for Starbulk. We saw a majority of orders coming through. Could that be the result that they feel unblocked a little bit from the regulations and unblocked a little bit from the geopolitical and tariff war?
I think that this is not exactly the case. I think that these ships were already ordered by the Chinese yards to be resold. So they were waiting for the right opportunity and the opportune time to make this sale to foreign owners. There is a clear sign from the Chinese government that they want to stop the reliance so much on foreign tonnage and to also strengthen the position of their yards. So these orders were existing. They're not new orders in terms per se. Some of them might be, but mostly it is already existing orders that changed hands.
Okay. George?
No, if there are any questions from the audience, yes?
Thank you, Mr. Chairman. A brief comment. We must understand where we are, where we're standing right now. The world is changing. The last 50 years, economics were on the forefront. And this changed. Now it's politics. And this will affect shipping. The economic era with the globalization was favorable shipping, more ton miles and all that stuff. Now, the reverse might happen. So we must have that in mind. Well, I had some other which I lost it. Okay, thank you.
Any other question?
Hello, yeah. Frederic from Value Maritime in Netherlands. I've been listening to you very carefully, and I'm a bit surprised, I would say. I mean, the United Nations, as well as the European Union, have the goal by 2050 to reach the net zero. So I would assume that the IMO is trying to find a way to meet this net zero framework, to meet this net zero objective with whatever framework we can try to define. And I heard a lot of critics, which are what they are, but I didn't hear a lot of solutions. So basically, I'm really keen to hear what solutions you are proposing to reach this net zero objective, if you still think it's worth reaching it. And I think we are a lot of people, especially young people, that would still like to live in a livable planet in 2050 and afterwards. So first question is, what solutions are you actually proposing to meet that, if we refuse any alternative fuels, if we want to continue on conventional fuels or LNG? And my second point is on the comment about LNG, increasing LNG imports from the US, which were saying it's a good news for sure for the Greek ship owners, and we really wish for the Greek ship owners to make more and more business. It's good for Greece, it's good for the European Union. But we also know that the LNG is coming mostly from the US, indeed, and is coming from fracking, which is something we don't want to do in Europe. We don't do in Europe because we think it's bad for the environment. And also, we want to go away from LNG at some point because we want to be self-sufficient with our energy in European Union. So yeah, I would be happy to hear your propositions to both meet this net zero objective and also in a way that we can be independent energy-wise as a European Union. Thank you.
Thank you very much. I can give you a practical example that maybe will help you see some light in the tunnel, because there is a huge dark tunnel that we're all in for a long time now with all the alternatives. Today's shipbuilding technology, and I will give you an example of Kamsarmax and Ultramax, delivered already 1.5 to 2 years ago, and it's the current model that comes from major Japanese shipyards, burning the fuel that we all know, the fuel that nobody has to question. It has a consumption at 11.2 knots laden of 12 tons fuel only, plus 2.5 for the auxiliaries. This, if you compare it with the eco vessels, the very, very sought-after ships, 5-year-old, 6-year-old, 8-year-old, 10-year-old, with the electronic engines, is down by 30 to 35% consumption vis-à-vis emissions. If you compare it with the MC-engined vessels, which is the majority, as Panos Zafet said, around 45% of the bulk carrier fleet are MC-engined today, meaning over 15 years old. Those ships, you have a comparison of between 55 and 60% reduction in consumption and emissions. If you looked at the slide that we read very quickly of how 2030, 2040, 2050 footpath is, already with 35 and 55% reduction, this is a very, very nice light at the end of the tunnel, which we can optimize further because R&D, AI, automations, technologies, paints, retrofits, and above all, new technologies that we maybe don't know today. We see rotor sails, we see wind assist, we see too many things that maybe today we have not invented them. So let's put our heads down to R&D, invent things that are practical and usable and can be applied on every vessel, even old ships or new ships.
So to answer your question, which is not an easy question, LNG is a bad thing. In my opinion, it's worse than conventional diesel because if you take it on a life cycle point of view for the environment, it escapes, especially at extraction. The average percentage of escape worldwide is 4 to 5%. Times 86 times worse than CO2, that makes it on a life cycle basis worse than consuming diesel. Now, many people may not know that hydrogen is a greenhouse gas. Many people may not know also that hydrogen is a very potent greenhouse gas. And latest studies after 2022, which everybody seems to ignore or they want to ignore or they want to bury them, and I'm talking about peer-reviewed studies by big universities, say that hydrogen in the short term is 60 to 200 times worse than CO2. I mean, forget what we thought in the past. Now it acts in 3 different ways to superheat the atmosphere. Not only that, it's the smallest molecule in the universe, so it escapes from everywhere. The escapes are supposed to be, a conservative estimate is when we go into this full production for the hydrogen economy, 10%. 10% of something that's potentially 200 times worse than CO2 will be emitted to the atmosphere. So I think 10 years from now, we'll all know that we took the wrong path at the cost of trillions of dollars. So what do we do to comply with the UN target of 1.5? Certainly, it's not hydrogen and the fuels around hydrogen. We can use some biofuels. If I had big quantities of biofuels, it's an okay fuel, I guess, to use in our engines, but that's not going to solve the problem. So in our anxiety to do something, we move from something that's what I call the lesser evil. Diesel is the lesser of all evils right now, in my view. we move to something that's worse for the environment. So the reply to your question, what do we need? We need new technologies. Unfortunately, we don't have them yet. Until we get them, like brand new batteries, light, with huge capacity, that would be nice. Nuclear, fourth generation, if I could put on my ship, that would be nice. We don't have it. Until we have it, we shouldn't move to something that's going to make things for the environment worse than what we do now with conventional fuels. That's my view. At least it's not my view, it's what I read in the studies. And I don't read headlines from newspapers. I read studies. So thanks.
Let me put you.
Okay, thank you. You know, it was, I think, a Monday morning when we read in the news that the previous Friday evening it was decided at IMO that by 2030 shipping should reduce CO2 emissions by 30%, by 2050 by another 50%, and then the net zero target came along. We cannot hold shipping responsible for those percentages. Those percentages were set without any scientific reasoning by politicians. And the fact that we found ourselves quasi-responsible to the society is our fault, but we are not the ones to achieve those targets. Ship owners do not manufacture engines, they don't make bunkers, they don't control the shipyards. When you look at the motors, the auto industry, it happens the other way around. When the regulator decides to limit the emissions, they tell the industries that by 2030, you will not be allowed to import cars in our country unless you meet those specifications. What happens to shipping? They go to the owner of the vessel, to the owner of the car, if you want to put it in parallel. They accuse us. And they tell us, you have a car and you're responsible, and by tomorrow you have to meet those targets. But I bought a car fully licensed. You see the disparity between the treatment of the various industries. Of course, it's the fault of the shipping that we fell into the loop, but we shouldn't take it further than that. Thank you.
We are living in a world that energy needs increase rapidly. In Europe, we are going to double our electricity consumption by 2050 by 100% of what we're consuming now. Already we have 50% of our energy coming from renewables. This is going to be 25% in 2050. Definitely there are going to be made new investments, but definitely we are going to need to import more energy resources. Every time we say good morning to ChatGPT or thank you, we consume the power of this room at least for 1 minute. So it's not a matter of where the energy comes from in terms of how you produce it. It's how you feel sufficient. You have, first of all, sufficient energy coming to you, and second, at a competitive price. Because of geopolitical reasons, now we are obliged to buy more expensive LNG coming from elsewhere instead of having gas coming from Russia. And this is a total political decision. And LNG is at least, at any price, 4 times more expensive than the gas coming from pipelines. It needs to be liquefied, transport, and regasified. So I don't, I hear all this argumentation about which is going to be the world that we are going to live in. we are not only Europe living in this world. We are only a small fragment of the world population. 750 million Europeans altogether to almost 8 billion of people living on Earth. And we only impose rules for ourselves without the others adapting. That will come to an end. Our productivity and our competitiveness will definitely be harmed. And we have to balance between competitiveness that we have neglected over the last years, together with the climate goals. And I think what has been said, it actually gives you a full range of different views to come to a conclusion that it's not shipping the only cause for global warming and the CO2 emissions.
Thank you much.
A very optimistic brief comment. I think that we're extremely lucky that in these challenging days of today, we have seen that the US is the major exporter of gas. Had it not been there, you could imagine in what position we would be blackmailed by Russia. Right.
Thank you very much for staying with us until this time. I would like to conclude this conference. We had 4 panels today. We started with decarbonization and the IMO decisions and what we can do about it. Then we discussed about technologies and innovations for the sustainability of ships. And the third session discussed about digitalization, AI, and how this digital ship management solution can help the ships improve their efficiency. And we had the final and last panel discussion enlightening us about all this political tension and environmental regulations. Before closing, I would like to mention that the next Greener Shipping Summit, New Technologies in Education, will be held again at the Evgenidis Foundation on March 31st, 2026. And the next Greener Shipping Summit of November will be also again held at Evgenidis on November 10th next year. So with this, I would like to thank everybody for staying with us, and goodbye.